Hey, what's going on, everybody? It is Friday, December 11th, 2020. I'm Brandon Toy, host of the Ranty with Brandon show. And we've got a good one tonight. We've got Mr. Sensible. I am going to open up the call with him, head over to his channel, and this should be interesting. We're going to talk about Mage 2. We'll see where it goes. I'm sure it'll venture into other areas. But I've got some tricks up my sleeve, and I'm sure he does too. And we'll talk about the horizon and all that. So shout out to everybody. I'm going to cut the shout outs a little short, but see if I can get through them. Page 42, Jeremy F.E., Anthony Burrows, Hellcaster, C4, Brandon Cook, Helen Degenerates, what's up? John D. Flathead, cat, go away. SE Montreal, and a whole bunch of other people. Lots of activity pre-show in the chat right here. Mr. Sensible is already live, so I'm going to go over there and give him a call right now. And then after that, I'll rejoin the panel. We can talk about what happened during the debate or whatever comes up. So it should be fun. All right, calling right now. I'll just put this over here. What the hell? Hopefully he answers. I was just listening live, so I know they're waiting for me. Hello? Yeah, it seems a little choppy on my side for sure. Let me see, and I'm live on my channel right now, just so you're aware. No, I'm here. Hold on. I should probably unmute. Can you hear me? Yeah, can you hear me? Hello? No, I'm fine with camera. I just hadn't turned it on yet. Shoot, you can't hear me very well, I take it? Camera seems to be working. Okay. No, that's all right. No problem. All right, excellent. I do. I have myself in the corner. Yes. Good. How are you doing? I was just listening to your show. Yep, sounds good. I'm not too worried about it. No problem at all. We'll figure it out. Yeah, I don't know if donated is the right word, but I guess it's as good as any. Ranty decided that he wanted to move on, do other things. He's got a new channel called Almost Unbelievable with conspiracy cats. And they're talking to different people, interviewing them about strange things that have happened to them. Ghost encounters, that kind of thing. Yeah, I know. It's pretty crazy. Ranty is a very good guy, very stand-up guy. Yep. I can't say enough good about him. Yeah, that's what I hear. So yeah, you invited me over here. Well, what exactly, I might have an idea of what you're talking about, but what exactly is your issue? One second, we might have some issues with the sound here. Oh, are you guys telling me in the chat that you cannot hear Mr. Sensible? Let me just check this real quick live on YouTube. Yeah, I saw that. Let me see if he's got if we have a problem here with the stream. Yeah, I saw that. Let me see if here, one second. Yeah, that's what I hear. So yeah, for some reason you're not coming through. One second, and let me figure this out. What's going on exactly? I don't know why. Probably the way that I have the audio set up. Sorry, guys. I apologize. Let me see what I've got going on here. Oh, shoot. Let me see if this will work. Dang it. Yeah. It's not. No, hold on a minute. Let me see if I can figure this out real quick. For some reason, this isn't picking up my my audio options for some reason, and it's just coming through the chat. Yeah, I think my headphones are grabbing the feed. Let me see if I can just fix this real quick, and we'll go do this really quick. Hopefully I can. Yeah, sorry guys. Just one second. No, go ahead. Let me mute you and I'll figure this out and I'll be back. Okay? Yeah, sorry guys. Just one second. No, go ahead. Let me mute you and I'll figure this out. Yeah, I can hear you. Can you hear me? Yeah. Well, unfortunately, that. Right. Yeah, I get you. One second. Let me see if I can just. Shoot. Yeah, it's not a quick fix, I don't think, unfortunately. I should have thought of this before. I do apologize for that. Let me see. Let me try one more thing and then we'll get going. And if we got to do it on your channel, we've got to do it on your channel, which is unfortunately. Okay, one second. Oh, it's so frustrating. Let me just give this a try one real quick.
I don't do that.
No, it's definitely me screwing it up.
It's not the easiest thing, is it, Brandon?
No, it's definitely me screwing it up. Let me just check real quick. I think I might have it. Come on now.
Fingers crossed. Fingers crossed.
Okay, let me just check the
Apparently
stream,
smart-
and if not, we'll just have to do it on your channel,
Okay.
unfortunately.
Oh, no, I just heard myself come back.
Fingers crossed. Okay, let me. Oh, yep, there you are. I got you now.
Okay.
Yeah. Give me a thumbs up. Oh, thank God. I already lost the debate. So now that I lost the debate on technicalities,
Yeah, that's right. And you've conceded everything, Brandon. Job done, I'd say.
absolutely got it. Oh my gosh, I'm so thankful. Okay, thanks guys. Thanks for sticking in there. Sorry about that. I'm looking at the screen like they're right there. Hey, thanks guys. Go ahead.
Okay. All sorted then. All sorted. Right. Back to the top then. So we were talking about Mage. The issue I had, because you and Ranty were both on the same stream, I think, talking about it, weren't you? Was that right?
Yeah. We were taking the piss out of Ranty or Rumpus. Yeah.
Yes.
And
So
Gleam.
even though he was saying a lot of things that were sensible, but then Ranty kept on using the wrong balloon, the balloon cam, which was a camera there. It was a wide angle camera. It was only there to look upwards at the balloon. It was not the experimental cam. You did use the correct camera from the full length video rather than the experimental video where I'd cut things down time wise, made some explanations, claims, showed some evidence, whatever. But then you took a number of shots, each of which were sort of diagonal, one way or another. So crossing from distorted area through to distorted area, basically rendering them worthless. You know that I did do a Mage response video. I don't know if you actually saw it. Did you?
I did. It's been a couple weeks, but
Yep.
I watched it. Yep, and I watched your videos, and I checked out the Mage 2 footage. So, yeah, I understand where you're coming from. So, your major complaint, it sounds like so far, is that we were looking at the footage from the wrong camera feed.
Well, that was it for Ranty, yeah.
Okay.
With you were looking at the right... Basically, 1 second. Meet Mage. This is Mage. You can see the two strings, yeah?
Yep.
So if you've got footage with those two strings, which as you can see is spring-loaded, you're looking at the correct camera. The balloon camera was pointing up here. The wide-angle camera is pointing out its arse. And that was just there for a good view because we're up there. So it's the this camera here with the string lines in front. That's what we need to see.
Okay, well, let's talk about that footage then. So you've got your Mage, you've got your contraption there with the strings, and you sent your video up, and I think you've done maybe, I don't know, a dozen videos in which you proclaim that you have captured the curvature of the Earth with your footage?
Well, I did an experimental video. I did from launch to landing with the experimental camera to show that I'd done no cuts or edits or cheats. So basically, you actually see me let it go, the full flight, it lands on the grass, it actually sits there for 30 minutes until I appear to pick it up. So you know that there's no cuts. Then I also showed the wide angle camera.
I couldn't get it to work last night, bro.
Yeah, I showed the wide angle camera just so that people can get a good view. No good to determine flat or curve, but just for a good view. And since then, I've done one other where I showed satellite imagery, which was from the same date and time, which matched the clouds that Mage saw to prove that it was actually up there. And since then, there's been a number of debunk attempts. There was yourself, there was Ranty, Level Earth Observer, Flatzoid again, and a couple of others. And so I've done a response to each of those.
Okay. Yeah, so my original, how I came across your footage was a couple of your trolls were in my chat saying, Mage 2 proved the curvature of the Earth. And, I found that funny to begin with because we've sent many high-altitude balloons up before.
Yep.
Flat Earthers, Globe Earthers, neither have sent them up many times. So we've all seen this footage from 120,000 feet, maybe even a little higher. So that kind of made me chuckle to think that they thought that you had finally given us the evidence that was going to prove the curvature and the globe. And then I ran across Fight the Flat Earth versus some Poe, I think it was. I can't remember who he was. He was one of those guys that he sets up to beat around for 2 hours and ridicule and laugh at flat earthers. So anyway, during this, he brought up that one particular image which I showed on the stream you're speaking about, which has the horizon down below the bottom string.
Yeah, let me be clear. You can use the word horizon without me jumping on you and saying, ha ha. Okay. Okay. Yes, we've got the horizon down below the bottom string. Yeah.
Yeah. What you say of the horizon is down below the bottom string. And I just thought that was funny that he's showing this picture of the horizon under the bottom string and claiming that proves the curvature of the Earth. I just thought the whole thing was ridiculous. The idea that you guys think that you have captured a horizon that shows curvature and that proves the globe. So since then, I've analyzed it in much more detail, and I've got some things we can talk about. But do you think that you actually captured the curvature of the Earth? Is that your stance, that you have scientifically proven it?
Scientifically is a big word. I'm not a scientist, okay? What I would, because someone picked me up and said that's not science, it's a demonstration. Look, as far as I'm concerned, whether you call it observation, demonstration, science, it doesn't matter. What it is I sent up a balloon with a camera, took some images. What do those images show? Okay. Now those strings are there as reference lines. They are in the image. You saw that. You can see that the strings, where are we? The strings are a fair distance away from the position of the camera, okay? So any distortion that the camera has distorts the strings. They're just something else that it's filming. So the idea was to have a narrow angle lens. I appreciate, I might be teaching you to suck eggs, but just to be clear, a narrow angle lens to get rid of that whole argument of a wide angle lens where you see the horizon bending and flexing like that on lots of those high altitude balloon flights, because most of those high altitude balloon flights are just going up there for other reasons, or even silly reasons like let's take some garlic bread up there. I went up there with a specific reason of trying to image the shape of the Earth, whatever that shape is, flat, spherical, or dodecahedron. So a narrow angle lens camera will have some distortion. Every lens has distortion to a greater or less extent. But by having those strings, you can see how much the distortion is. And in fact, in the video, even you've seen those strings, they are straight, they are taut because they're spring loaded. But in the video, there is a slight curve to them because of the distortion. So we know that there is some distortion. I wasn't hiding that. So there's a couple of things you can do. You can take that image with the slightly distorted string, undistort the image, which is not a dodgy thing to do. You undistort the image and then see what the horizon of the Earth is. Is it flat? Is it curved? Whatever. But with barrel distortion, you know that at the top, if we use my screen image here, at the top, it gets bent like that. At the bottom, it gets bent like that, yeah?
Well, it's not just the top and the bottom, right? It's the
no, it's sides as well.
Sides,
it's sides as well. Yes, yeah. But we're working with a horizon from side to side. Okay, so if the horizon is bang in the middle, and it's a flat horizon, it will appear flat. If it's a curved horizon, it will appear with a curve. Now, the higher up the field of view you get, the more it will get distorted. Even a flat Earth would get distorted slightly, wouldn't it? Because of the barrel lens distortion. If the flat Earth was down lower, it would get pushed down. Yeah? I'm saying we've got a slightly curved Earth. If you go high, it will look even more curved. If you take that slight curved Earth, go down, it would try and flatten it. Now, that's what we've got, because we got the string bowed down, but we got the horizon still bowed up. If it was a flat Earth, how did it bow upwards when the deflection, the distortion, is downwards? That's why they showed that bottom image. Excuse me.
Yeah, so I understand your hypothesis, and okay. I would say that this is all predicated on the idea that what you have captured is, in fact, the horizon. So I have a question for you, if you don't mind. based
course
on
not.
some other document that I've seen passed around. And I don't necessarily stand behind what this says, but let me just share it on my screen and with you, and we can see what your thoughts are on this before we go any further. 1 second here. Okay. And let me share.
While you're just working it out, apparently Flatzoid is in your chat. Hello, Flatzoid. You're going to do another Mage debunk or just remain 3 times on the list? Right, here we go. Brandon's presenting.
Okay, hopefully you can see my screen now.
I can see the sort of mesh sphere. Yeah, okay.
Yeah. Are you familiar with this diagram or this line of thinking at all? Let me describe it.
Just resize. I'm just resizing this and hope it doesn't screw up everything I've got. Let me just have a try. 1 sec.
I can make the top bigger.
Oh, it's just disappeared again.
Okay, I won't touch it again.
Switch it off.
Nope, it's still on.
Now it's come back. Yes, it is a bit bigger. Oh, now it's gone again. Right, I'm not going to move over. Wonder what? Oh, it's coming and going. It keeps. Oh, it says pause due to network problems. It appears and disappears.
Oh, you're having some network problems, maybe.
Well, I wasn't.
Well, I can.
Go on. It's there.
All right. Well, I'll try to describe it and get to the point. Hopefully, you can see it in between. Okay. So there is a school of thought within we'll call it the globe community, that you can view the horizon from certain heights. This document would say that horizon circumference approaches 90% of their circumference at about 5140. Unless the observer is very high, more than about 80 miles, the curvature he sees down below is just the curvature of the horizon circle, not the curvature of Earth. Do you understand what that means?
Yes, I know what you say. Like as though you were over a flat disc. That's what you're saying. That curve is the edge of a disc, in effect.
Okay. Is that what this means to you?
Sorry, is that what you're talking about?
Yeah. So it looks flat from the side. You have to go up 80 miles in order to see any curve. That's how I interpret this document.
Whose maths is this? I'll be honest and say I am not a mathematician. I do know that a very good person who's excellent at maths. You heard of Walter Bislin, I presume.
I'm familiar with Walter Bislin's, of course.
Yeah, who did the Earth curve calculator and things like that. He has taken those Mage images and used his Earth curve calculator, whatever, it's worth having a look at his site. And the curve matches what Mage shows against those altitudes that Mage reports.
Yeah, I understand that you think you've matched the horizon curvature with the curvature in certain frames from your video. But what I'm asking you is, are you of the school that you can see the Earth curvature at what height? What height would you say you have to go up before you can actually see Earth curvature? I'm just trying to understand where your head's at in relation to being able to see the geometry of the Earth were it a ball.
I suppose I couldn't put a height on it. I really couldn't, because even at the height Mage was at, which is 37 3/4 kilometers, 23 miles, whatever. It's not a lot. It's not going. It's not like you're going to look up there and wow, look at that ball. It's only slight. We're only talking about a few degrees of curvature, because even with those images, the best of those images, you can think and look at them and think, do you know what, that does look curved, but it's only when you put a line across it you can see the curve. Prior to that, it's not glaringly obvious. So I mean, technically
5,000 feet,
you could probably see it from lower down, but you'd need better equipment or whatever, and very good conditions. But I couldn't put what that height is. I wouldn't know.
Are you of the school that it's possible, theoretically, if you had really great equipment and a really clear day, for you to see the curvature of the Earth were you standing on a beach looking out over the ocean?
I think, well, I suppose in the strictest technical sense, I would say yes, but I think in reality the answer is no, because you just couldn't be that accurate. And of course, what we often hear is people saying, well, why isn't there a curve? The problem is, if you're sort of 20-mile distance there. If I look over there, the horizon's again 20 miles, 20 miles. It's like looking, putting a hula hoop around your head. It's going to look the same distance all the way. You're not going to see that as curve.
Right. So you go up higher, you see further, and then
Yes.
in your mind, you'd see the slightest curve possible at ground level, let's say 6 feet off the ground on the ocean. Looking at let's assume it was perfectly flat. Would you see, if you could measure it optically, would you be able to see a curvature from that down below? Meaning you would be looking out, the horizon would be Earth curvature at that height, or is there some height above that you have to go before you see the curve of the Earth?
Well, you're talking about ideals here, ideal conditions, ideal measuring instruments, and so on. Have you seen that photograph? I've forgotten who it was, with 2 spirit levels, and he takes one photograph, and you can see the curve. I mean, it's going to be there, but I mean, you're talking. I mean, the slightest bit of refraction. I know it's going to be a dirty word, but do you know what I mean? The slightest disturbance in the atmosphere, and you're going to screw it. I honestly, it's not trying to get out of anything, but I honestly don't think it's something that's worth worrying about, because anything that could be measured is going to be so tiny that there's no chance of seeing it by hand. For some reason, I'm only showing. Let me see if I could.
Oh, do you still want to see this? I'm sorry.
No, it's not that. I can only see. Oh, right. You got the presentation. Can you stop presenting? Is that right? It's just that all I've got is, it just says presentation Brandon Toy. It's not showing anything else.
I think we're good with that. So, okay, but at some point, as you rise up in altitude, you will be able to see the curvature. That's what your entire thing is predicated on. That at some altitude, then the curvature will be, you will have the ability to see the geometric edge of the Earth.
It will get more and more obvious until, for instance, if you're at the distance of the moon, it's a little, it's what, 4 times the size of our moon in the sky. Do you know what I mean? Yes, you get higher and higher. It will look more and more curved until it's a circle some distance away from you.
Okay. All right. I understand. So I think I know where you're coming from. So my next question would be, how did you determine that what you were looking at was the geometric horizon in your Mage 2 footage?
How do you mean? Whichever direction it was pointing.
No, I understand how you determined that the shape was either curved or flat or concave, convex, whatever you want to say. I'm asking you how you determined that what you were measuring was the horizon, the geometric horizon of the Earth.
Well, okay. Well, the only other thing it could be, I guess, would be the atmosphere, wouldn't it? Can you think of anything else it could be?
Essentially the atmosphere, darkness, particulates in the air, water vapor, that sort of thing.
Okay. So let's say we're looking forward. We've got what is apparently a curve, but could be due to clouds, atmosphere, whatever. Why is it when I look over there, I get the same curve, and over there I get the same curve? If looking in that direction there was a lot of clouds piled up or whatever, despite the fact we're way, way above them, why is it exactly the same over there? Exactly the same over there.
Well, you've got the same dynamics no matter which direction you're looking at outside of the clouds, which I'm not talking about clouds. So the atmosphere is, from the ground level up, it's a certain density, right? It's got you've got a certain particulates in there. Yeah, it's a gradient. So from the ground up, it's heavier and more dense, and as you go up, it's less dense. And you can calculate from your position around you how much atmosphere is, say, 100 yards away from you, 100 miles away from you. You could calculate that no matter which direction you look in. That's going to be generally the same value. So you do have kind of a circle of sight around you, and that's what you did. You sent a camera up and it spun around and looked in all directions. I would expect to see very similar effects from atmospherics in any direction that you looked.
In which case, surely you just busted yourself in that if it was identical conditions in every direction, it would look like a flat circle around you, wouldn't it?
Why would it look like a flat circle?
Because if I'm looking straight at you and you are at the peak of that curve because of atmospheric, why is it slightly lower there and slightly lower there?
Slightly lower.
Because
I'm not sure I get what you're saying.
same
Slightly lower. What do you mean slightly lower?
What, bent down? Why would it bend down if the conditions over there are the same as the conditions there, the same as conditions there? Surely everywhere would look the same.
Well, it'll look the same in any distance in a radius around you, right? So wherever you look, if you look 100 yards to your right, it's going to look the same as if you look 100 yards to your left. It's going to look the same, or 100 miles.
Looking about 400 miles, I think it was.
Is that what you calculated? 400 miles to where that horizon is?
I think it is. It's rough. That sort of.
I don't think so, but so my question.
Well, we know so because, and obviously I can't expect you to have known this, but it's using GPS trackers, so it receives signals from satellites, broadcasts its position. That's picked up on the ground by radio stations, radio receivers. People are into high altitude ballooning. So when we took off, there was only the local tracking station, if you like, could see it. As we go higher, tracking stations further and further away could pick it up. And let me see. Oh, actually.
Well, hold on a minute. So you're saying, what is this about GPS? How did you determine the distance that you could visually see from Mage 2 using GPS?
Right. If you know exactly where you are, okay, let's pick. You're in America, okay? Now, let's pick some, I don't know, let's say you're in Chicago, for the sake of argument. I have no idea if you are right, but let's say you're in Chicago, okay? And you're a height of, you're launching a balloon in Chicago. So your balloon picks up signals, GPS signals, just like your sat nav does, okay? So it says you're in Chicago. You broadcast a signal and say, hey, everybody, I'm in Chicago. But you're virtually at ground level. That signal's not going to get very far. When you're a couple of miles up, your radio signal can be received by stations further and further away. When you're 10 miles up, stations further and further away, until you're 23, 24 miles, whatever Mage was at, it can be picked up by stations 400 miles away. They can't pick it up until you're high enough because the curve of the Earth's in the way.
Was it picked up by any further stations that 400 miles, or what was the capability of the GPS transmitter or whatever you used up there?
Yeah. It's only a tiny little transmitter. It uses just a single AA battery. 1 second.
Okay.
Fits in there. This was one of the 2 trackers.
So how far could it transmit? How far was it capable of transmitting?
Well, there's no limit as long as there's nothing in the way.
Well, did you attempt to pick it up further than 400 miles away?
Well, we can't attempt. We're just broadcasting from that height. Other enthusiasts who are tracking balloons pick it up from wherever they happen to live. So
who picked it up?
Well, I don't know. I don't know who they are, but they just give their locations, and then what they do, you see, is having picked up the signal, they upload it to a tracking server. Okay, so what we've got, so that's our telemetry data. When we finished, we go to the tracking server and say, yep, this is our balloon, can we have the data? And we get all the timestamps and locations that were reported by various people around the country. I mean, I started to say, but I did a video that shows satellite views from 3 independent weather satellites that show the weather over the UK on that day. It was pretty cloudy, but there was a very, very unique cloud pattern. It's basically all clouds with 1 long clear strip and 2 large bare circles. And Mage photographed that, but you can see that on all 3 of these weather satellites. The thing was, we were sort of central UK.
Can you show me that on the picture or something?
I will try and show you that in a second. Yeah. We were central UK. Those bold patches were well over Ireland. So let me see if I can.
How do you know the signal couldn't be picked up further than 400 miles? That's what I'm asking you.
Well, maybe it could, but if no one's picked it up, we won't know.
How many people picked up the signal from your from Mage 2?
I don't know.
Oh, they did. I thought you had some data that came back, like they picked it up and sent it back to you.
I have the telemetry data which says, I don't know, 1252, 10 satellites. This is my GPS position. This is my height. And there's a couple of other figures in there.
Okay.
That's all I
So
have.
you don't know if it could have been picked up at 500 miles, 600, 700.
It might have been picked up further, but
but you don't. But
with the
that data
global,
wouldn't
for instance, it's
necessarily
not gonna
come
be
back
picked-
to you.
It wouldn't necessarily come back to you if no one's there to do it. But also,
Okay.
it's only going to be picked up a certain distance. For instance, if someone was on the east coast of America looking out for balloon signals, they wouldn't pick it up because the bulge of the Earth is in the way.
So you contend. So you contend. Okay, that's all I wanted to establish was that it is possible that it could have been picked up further than 400 miles. You don't have any substantive proof that it couldn't have been picked up at 500 or 600 miles. You just didn't receive any data back saying that someone actively picked it up and sent it back to you.
Well, what you can do is with the software, the high altitude ballooning software, it's basically overlaid on sort of Google Maps or whatever. So you've got your location because it's got the GPS position. As it goes up, the software draws a circle getting larger and larger. Like you were talking about on your diagram, with the circular view, that circle gets larger and larger as you get higher. Just like if you go up in an airplane, surely you don't contend against that. If you go up in an airplane, you can see a long way, a lot further than if you're stood on the ground. Yeah.
Do you think that I'm arguing that you couldn't see at 400 miles, or what do you think?
I'm just trying to make the point. Okay, if you're stood on the ground, you can see so far. You stand on a tall building or a mountain, you can see further. It's exactly the same concept, but with Mage, at the height she was at, in effect, although she couldn't see, she could be seen from about 400 miles.
That's your guess. That's a guess, essentially.
Well, okay, or that's what it would be.
I mean, you didn't have any mathematically on the globe, correct?
No, hold on a second. That's what it would be mathematically, and none of the data contradicts it.
So, how did you determine that it was 400 miles?
Well, I am not a high altitude balloon expert. I am not a mathematician. The guy who helped me is a high altitude balloon expert. Expert. He's someone who's done masses. He has all the software. He has equipment. He loaned me a lot. It saved me a lot of money. I was very, very grateful. And you can see it real time. I mean, this thing went up. We could track its position from the launch place to the landing place. It was about 40 miles. We were able to get signals from it, to his phone. And so, the balloon's burst. We know it's burst because instead of slowly going up, it's suddenly rushing down. So we tracked it and we actually parked up and we were looking there. Where is it? We could see it was coming down roughly 1/2 to 3/4 of a kilometer away. We didn't actually see it come through the clouds, but it landed 750 meters away from us.
Oh, wow. That's not very far at all.
No. But we only knew that because it knew exactly where it was because of its satellite signals it received. So it calculated its GPS position and broadcast it.
Sure.
And so we knew where it was.
Okay.
And of course, then I was able to walk up and find it 40 miles away from where we started.
How far could you see in the Mage 2 images in your video at the highest point, the apex? What is the distance visually that you could see?
Well, like I said, I think it's about 400 miles.
400 miles you calculated based on the ball and based on the fact that you had some signals come back to you from GPS, but it might have been picked up further. You don't know. You can't exclude that.
Well, I think we can because nobody ever at that height would pick up anything further away than whatever that.
You told me earlier that it was possible that somebody at 500-600 could have, but you just didn't get any data back saying they did.
Okay, and I did say that, Brandon. Let me be clear, okay? The 400 miles, to my knowledge, is roughly.
Okay.
Maybe it's 500. So you can't hold me to that because I'm not a balloon expert. Okay. It could be a bit further, but there'll be a limit, something of that order. For instance, there's no way it would be 5,000 miles away. No way at all. Okay. So it might be 5, it might be 5.5, but it's roughly of that order.
How have you ruled out that it could not be your visual distance that you could see in that imagery wasn't 5,000 miles? How have you determined that?
Well, because it's no, it's going to be
is that
a bit of a
based on your ball model math?
It's a ball, you can't see further. But what I'm doing, let me just call up this imagery that I said about this satellite imagery, because it is really interesting. I'm going to have to hope that I can share okay with that any issues. It's not the easiest thing to do. I'm not that keen on Zoom, but
somebody wanted me to point out, Flatzoid, who you're familiar with, that after 3 hours of flight time, the balloon, there was no Coriolis and it landed 750 meters away. But we don't need to go into that. We don't need to go into it. But
we don't need to go into it. Let me just say, that's because Flatzoid hasn't got the faintest idea what Coriolis is. I did say to Brian's Logic to do a video on Coriolis, and he has done a little thing. Flatzoid, if you do a video on Coriolis and why you think that with the globe model, Mage should have seen the Earth turn underneath. If you do a video on that, I will respond to that one, okay?
I've done a good video that I haven't gotten a good response to, a satisfying response, which is called Impossible Ball Flight. It's on my page having to do with Coriolis. You should check that out sometime.
Impossible what?
Impossible Ball Flight, I think. Something like that. I can't remember the exact title. But anyway, so you're going to show me the satellite data, and what is this going to establish?
Yeah, well, I am trying. Just calling.
Okay.
I have to be careful because... Right, let's just see. Let me try presenting now. A window.
How long was the flight time again, did you say?
About 2 3/4 hours, something like that.
Okay.
Right, okay. Can you see that?
Yes,
nice
I can.
Picture of me?
Yep.
Okay. Right, so what we've got, I'm going to whiz it forward. So, yeah, I'll show this bit first. Come on. Actually, it's too low. Let me go back a bit further. Can you see above my head? You've got this sort of triangle, this clear area of blue.
Yes.
Okay. Then as we go higher, let me just. I'll mute it. We don't need the sound. You can see. Let me pause it there. You see, you've got this line down towards me, and over there. You've got 2 circles or bare patches of sky.
Sure.
Yeah.
Sure.
Now, we've got that. That's currently at 14,000 meters. If I do it again at a higher height, so this is 38,000. Let me just play it. So, that's too late. Let me go back a bit.
There's the ball. There you go.
No. Actually, that's wide cam there. Here we go. This is at 14,000 feet. So you've got that. It's not showing. It's not the best view of it. I don't know exactly where it is in this video. Let me rotate it. Right, there you go. So that's facing eastwards. You've got that long bare stretch. All the rest of the sky is cloud. Then if I let it carry on, so it goes round. Go on, play. Goes round. Come on, turn round. There. You see, you've got 2 areas that are bold.
Sure.
Yeah. Okay. So that was the main premise of this video. I show it at various heights. I then call up. Let's just go to it. Some satellite data. So this is the eye in the sky on that date, 17th of October. If I just play the video. Right. Let me pause it. There. Can you see? I don't know if is the mouse showing. There's the long streak.
I see. Yep.
Yeah, and there's the 2 bold bits. So you can see the outline of the UK. So those 2 bold bits are right across from the edge of Wales across to, that's Ireland over there. And we were somewhere over here. We could see from pretty much central England right across to and beyond the near coast of Ireland. So that scales it. That gives you proof that I was, or Mage was up there at that time. And in fact, if I go on to another satellite. I think this satellite wasn't quite so clear.
By the way, I have no doubt that you sent the balloon up.
No, I
yeah.
appreciate that, but some people could. So there again, you can see there's the two bold bits. Oh, let me pause it. Oh, come on. I had fun and games with that. There we go. Yeah, so there's the two bold bits, and it's harder to see, but there's the bold strip. But the third satellite, if I go onto that, so these are three independent satellites. This was a brilliant image. So there's the bold bit across the middle. The long streak, and there's the two bold areas, which matches up. And if I pause it there, come on, pause. So there we go. We've got the coast of Ireland over there. You've got the coast of Wales here. We were over here somewhere. We could see from central England right across and beyond to the coast of Ireland.
Okay.
Because there you go. So there's a good image looking across. So there's the two bold bits.
You can see at least that far, yeah.
At least that far.
Sure.
So the coast of Ireland is there. We can see beyond.
Yeah.
So that just gives you a sort of idea. Okay.
And this is at 24,000 meters, so you're about
that's at
2/3 of the way up.
Yeah. Yep, something like that.
Okay.
Yeah.
Sounds good. What does this establish in your mind? Just that you can see that far? Is that it?
The reason I did this video, because it was independent proof for those who would deny I'd done it. It's independent proof that Mage was up there, because the film I produced and had already published matched what was on websites for three weather satellite, or two weather satellites and a NASA satellite.
Gotcha.
Okay.
So I think we've got away from my question a little bit, which
probably
was
not intentional.
No. That's fine. My questioning took us away too. But how is it that you determined that what you are seeing is visually the horizon? Because I'll be honest with you, when I look at your images, it doesn't look like the horizon to me. It doesn't look like the geometric ball edge.
What does it look like to you?
It looks like as far as you can see, the limit of your vision based on atmospherics, and what is it called? Compression at the horizon due to distance, increasing angle. Just as anything else, when you look out towards the horizon, the further you go, the more things compress, the more atmospherics impact what you see, and then possibly in the back, it looks like darkness, possibly.
Darkness.
Yeah.
Sorry. I'll think and look to answer. I don't know if you've got any super chats at your end. Have you?
Yeah, I think I've got one. Yeah.
Okay. Should we do super chats and then I'll try and answer that?
Yeah.
I've only got one to read out. It's from Mr. Mark Wagner for $10 US, saying, "Mr. S, here's $10 for your next worthy venture. You are wasting your time with this guy. What an idiot! Intolerable." Okay, so that's what Mr. Mark Wagner says. I'm sure that people at your end have some interesting things to say as well. Brandon.
No, I hear that about 10 times a day. Flat for Life donated because I couldn't get it to work last night, bro. Thanks, Flat for Life. Appreciate it. And that's it for now.
Oh, okay. And I've been asked to fix the screen size. Apparently, I've managed to screw it up. My apologies, people. It's because there we go. Are you happy now? I'm sorry about that. It's all too easy to mess things up, isn't it, Brandon? Okay, so you were asking about what you saw, what Mage could see. So I'm not quite sure I think I understand your question, but I'm not quite sure what you're intimating, because you said about blackness. If the sun is shining, well, we know that half the world, whatever shape it is, half the planet, world, disk, is lit. So it was early afternoon when Mage was up there, say about 2 o'clock. So right across Ireland would also be daytime.
Yeah.
And most of the Atlantic, and I guess on the eastern America, perhaps it was first thing in the morning, perhaps it was dawn. I don't know. So why would it be dark? How could I be seeing so far? It's it's dark all the way round, the same distance.
Yeah, let me show you what.
If I'm seeing, let's say 600 miles. Let's say I could see 600 miles. That would make the daylight portion of the Earth 1,200 miles across only.
1,200 miles across. Where'd you come up with that number?
Well, if I can see 600 miles this way, 600 miles.
600. I missed the 600 part. Okay, miles. Got it.
Okay.
I just didn't hear you say 600. All right, let me go back to my slides and I'll share.
That's fine. That's fine. I'm not going to hold that against you.
Okay, so let me share here. Hopefully you can see it okay this time. Let me know when you see it.
It's presenting, and it's showing a it's some graphics package with some Mage images in, by the looks of it.
Oh, am I sharing the wrong one?
Might be.
Okay, that's not good. Oh, 1 second.
While you're just looking at that, the Snark super chatted €2 saying, "Can you show your images in my video? Would be fun." I'm sure it would be Snark, but I'm only gonna anything I present will be stuff that I'm fully aware of. Not be funny, as you can see, it can be difficult enough to do presenting and stuff as it is. Brandon's having some fun and games, getting some stuff sorted out right now. Yeah.
Okay, I think you should see it now. Sorry to cut you off.
No worries. Yeah, I can see it. It's part of a Mage image with the two reference line strings. Yes.
Yeah, I had it zoomed in a little bit, but yes, this is a Mage image that I took from the end of your Mage 2 video.
What's that height? Is that the 36,000 meters?
It's 35,300. It looks like. So.
Right. No. You read it in that little. Oh right. No, it's 35,162. You can read it at the top. You've got it in white and red. Out M and out max M. Top right.
Oh yeah. I was looking at this. Okay. I thought this line for a second was
No. That's one of those two strings. The black box has the same figure.
Okay.
Well, there may be a drawing delay between the two. It's basically the same. So it's 35 kilometers up. Yeah.
Yep.
Okay. Go ahead.
Okay. So when I look at this image, I don't see a geometric horizon.
Do you see curve? Does that? We'll call it horizon just for the sake of ease. Okay, I'm not going to hold you to that. That line, that horizon, does that look curved to you? Whatever the reason, does it look curved to you?
Where is the horizon for you?
No, you know what? Okay, from where? Okay, zoom back out. Zoom back out again.
Sure.
You've got black above, and then a band of gradient of blue, and then pretty suddenly it turns white. So it is difficult to pick an exact point because it's not like something you can see exactly and zoom in that gets you close. So you zoom in, it looks harder. But you can see, let's say the top of that whitish area. Does it look dead straight to you, or does it look bent?
Well, so what you're calling this is the top of this white, this blue line.
Yeah.
You're saying that is the geometric edge of the Earth, correct?
That's the top of the clouds and the thick atmosphere.
Okay.
And it's so far away that it's not like a cloud, is up, down. It's so far away, I can see beyond Ireland. We're talking several hundred miles away. So it's just with perspective, it's pretty much all ironed out so that it's, there's no up down from clouds. You know what I'm saying, don't you?
Yeah. So what I'm saying, what I'm trying to tell you here is that when I look at this image, I don't see a geometric Earth curvature here. I don't see a hard horizon. I don't see a hard horizon at all. What I see is the limit of visibility, and I see more clouds or land or whatever going off in the distance past this point where the atmosphere is so thick that you can't see through it anymore. That's what I see.
Okay. You see the telemetry numbers up there at the top? It says 10 satellites, 466 pascals, which is actually about half a percent of the atmosphere. There is virtually nothing up there.
No, I understand that where Mage 2 is, that there is not a thick atmosphere. I understand that.
Yes.
But what you're doing is you're looking down at such a steep angle across the Earth, and you're looking down into the atmosphere. So as this horizon goes away from you into the distance, this compresses. You get more and more physical space compacted into less and less visual space, so that by the time you get to, say here, where the atmosphere keeps you from seeing any further, one hair width is as much as half of this up here.
I know what you're saying about perspective, but then if that's the case, what's all that blue stuff above it?
What blue stuff?
Okay, you've got that line, the top of the white, which is perhaps where this alleged compression is. What's the blue? Sorry, I'm waggling my mouse so you can see it. What's the blue then fading to black above it?
Yeah, see how this changes color as it goes from white, and then it fades into this green, and then it fades into this blue.
Right, I will have to stop you there, Brandon. I'm actually slightly colorblind to red and green, so that doesn't help with that.
Oh, geez. Okay.
Have you?
You know, at the top of the white, there is a different color. Do you see that variant of gray or whatever color it is?
See, okay.
Anyway, this goes from white to dark blue as you go up, right?
Yes, but you've got white, maybe towards a green, but then very suddenly it changes. And you can see a line there, surely. And then above, it's a nice smooth gradient to very dark or black or whatever it is.
Sure. Up here, this is obviously above the Earth. Yes. Yeah, I agree with you that most of this is above the Earth over here, or, you can't see anything. But down here, what it does is it goes from white, and then not very suddenly, because you have to remember this band right here that looks green but is a different color from the white as it moves into the blue is a very long distance, probably further than half of this down here, almost certainly further than half this. So you're looking at a lot of atmosphere condensed into a very small space. Hence, of course, it's going to change colors faster. You're going to see the atmospheric effects rapidly change as you look away from you, as you're looking through that smaller and smaller visual space that represents larger and larger physical space.
Okay, so we're at 35 kilometers. What about when we were at sort of say 15 kilometers, about half that? Okay, if you're looking horizontally, you haven't even got the advantage of being in this really rarefied atmosphere. There's a lot more atmosphere, and yet you don't see this curvature effect. You'll see a blurring out if you looked horizontal. You won't be able to see so far. But what you don't have is that such a pronounced curve. Why is it looking more curved the higher you get? I appreciate what you're saying. You're looking through more atmosphere, but why should that make it look more curved?
So you've got this limit of what you can see, and that's naturally, I think that's why this is curved. That's my hypothesis, is it makes a limit of vision around you, kind of like they're trying to show in this, right? So from the side, a circle, if you were in and your eyesight was on the same plane as the top of this cylinder here, and you were looking at it, it would look like a flat line. But as you raise yourself up above, that circle of sight is still around you, and that will make it look a little more curved as you see that limit of your vision.
I mean, I know what you're arguing there. Obviously, I disagree. So I just want to check.
But I mean, this is what I'm saying. This is a subjective thing here. Looking at this picture, you have decided that because of the appearance of this, that what you are seeing is Earth curvature. And I'm telling you, when I look at this visually, it doesn't look like Earth curvature, and it matches my model of how things should work on a extended flat plane. And just let me show you another picture, because it's actually doesn't have the blues in it, so it might be better.
Okay.
I messed around with this picture and tried to enhance it in a couple different ways, and you can see here I messed with the color levels.
Yeah. That helps.
You
That
can see
helps.
the green more pronounced here, and it's interesting. There's
And
there's
you can
kind of
see the
more
curve
green on
more
this side
easily,
here.
Brandon.
Do you see this over here? How this green is more over here? Why is that? Why does the thickness of this other color that's right on what you think is the horizon increase, or why does it thickness increase here?
You're sort of quite a distance towards the black string there, aren't you? As I said, I can see a sort of to me a turquoisey color. You'll have to ignore if I'm wrong about the color. I can see a sort of turquoisey area, but whether that's clouds or ocean, you know what I mean? If that which direction, I'm not sure which direction that is, but whether there's the ocean there, it's thin. I don't know, but there is a slight discoloration there. But you have got a very definite curve to that. Why?
Yeah, well, I
what you're
just
saying
I
is
just
because
explained
how
why
far you can
it's the
see.
limit of your visibility, which is going to naturally look like a curve. But let me show you this one here. Maybe this one's the better one. When I look at this picture, this is just I changed the color levels. You can see it draws it out, and you can see more of what is behind that kind of blue-black. So it draws some of those colors out and shows you that these colors that you were seeing in here, this effect that you were seeing here, goes off into the distance, and it's pretty interesting. You see this.
Can you zoom into that a bit?
Yeah.
Can you zoom into that a bit?
Yeah.
What's that line?
Oh, this line right here. Yeah, these lines. Yeah, these kind of come and go. I think it's just another layer to the atmospheric effects, or something to do with the sun.
They do happen to follow the same curve. But actually, if you can just zoom out again, Brandon, please. And can you go back to the previous image? I appreciate what you've done with this, but go back to the one with the blues, the greens, and whatever.
Yeah, okay. I haven't gotten done explaining that one. We'll go ahead.
No, I appreciate it. It's just back to the first image you looked at. Was it? I think it might be that one. But we've been sort of talking about the top of that sort of whitish area where you say it goes sort of a greenish area. If you look up higher still, where you've got that blue fading out to black, i.e., you're now looking right across the top of the atmosphere where there is very little atmosphere, you still got that curve. It happens to follow the same curve, but you're looking for a lot less atmosphere. But perhaps, please carry on with what you were saying. You had your colorized version.
Yeah, you're always looking, the further you look, the more atmosphere from your position you're looking through. So if you're looking down here at the ground, it's a lot less atmosphere that you're looking at when you look out here towards this color band area. And it increases exponentially as you go out.
Up to a point, though, Brandon, because, we're at 35 kilometers, I think it is. Yeah. So if you look straight down, you'd be looking through 35 kilometers of atmosphere. If you looked sort of at an angle of 45 degrees, you're looking at, I don't know how many kilometers, let's say 80 kilometers of atmosphere and so on. Yes, it's getting more and more atmosphere you're looking through until you're looking sort of above the ground. Then you actually reach a point where you're looking over the top of the sphere, in effect. So you're not looking through those thicknesses. You're looking, if you're looking absolutely horizontal at 35 kilometers at half an atmosphere, you're looking through half an atmosphere's thickness over a long way, but only half an atmosphere's, sorry, not half, 0.5, half of 1%'s atmosphere, 0.5% atmosphere. So it's hardly any there.
Yeah, if you're looking horizontally, we have no disagreement about that. This is the least amount of atmosphere you can look at. Here's what okay.
Yeah, but that's what I'm saying. You see, if you're looking just below horizontal, you start looking through that faded gradient blue.
Yeah.
This curve there. Why is there curve there if it's due to atmospheric distortion? If there's no atmosphere to speak of.
There is atmosphere to speak of. I don't know why you're not saying that. Where do you think that there is an atmosphere? Tell me where you think the atmosphere stops. I'll move my mouse up. Can you see my mouse?
Okay. Oh, the point I'm talking about. Go on, move the mouse up a bit.
Okay.
Up a bit more. Okay, right. Just stop there. Now, there is atmosphere there. Absolutely there is. That's roughly horizontal. Let's say it's horizontal. That's about 0.5% atmosphere, 0.5% atmospheric pressure at that height. You're looking through a lot of it from a long distance, but it's only at 0.5%. Why is that? If you follow your mouse to the left and to the right, why does that also follow exactly the same curve as that sort of white to green turquoise or whatever? It's the curve of the Earth.
So you're but
atmosphere's
you're
following the shape
thinking
of the
we're
Earth.
thinking two different ways. Okay, so you're thinking that you're looking out over a ball when you look in this direction. That this is the edge of a ball, and in that case, I understand what you're saying. You'd be looking out over. There's not very much. There wouldn't be very much atmosphere here. But if you're looking down on a flat plane, there is a lot of atmosphere here. Right here. This would not be just out over the curve of the Earth. This would be down into the atmosphere. Down here is down in the atmosphere. This is down in the atmosphere, and more atmosphere. This is more atmosphere, and wherever the land stops up here, which you can't see because it's blocked by all this atmospheric effects, this condensed atmosphere.
But if let's say, for the sake of argument, that that is a flat Earth, you've got all this. There is no rises to eye level. It's not going to keep on. Do you know what I'm saying?
Well, I don't know where it rises to.
is-
I don't know where it rises to because you can't see that far. But I understand this.
If you're looking
I'm not-
horizontal,
Yeah.
if you're looking horizontal, if you are above a flat Earth and you're looking absolutely horizontal, then every bit of that Earth is going to be below you. It cannot be above you.
Are we looking horizontal? But we're looking. This is a visual thing. This is an optical thing. When I put my cursor here and say, look in this direction, I'm not talking about the Euclidean physical model. I'm talking about this picture. And if I look at this spot on the ground and drew a line from me to this spot on the ground, I would be looking through a lot of thick atmosphere on a flat plane.
Yeah, but what? No, I appreciate what you're saying.
But where? Hold on. Hold on. I understand I get what you're saying.
Okay.
Okay, I do get what you're saying. It doesn't rise to eye level. It doesn't matter. Is this picture at the point when the camera is perfectly horizontal?
I can't tell, but I tell you, excuse me, I can't tell, but I'll tell you probably can. That's Walter Bisling's, because he did do calculations and worked out horizon drop. I'm not a mathematician, and yeah, you're quite right. How do we know from that one picture? Because Mage tilts and rocks. Absolutely, I can't dispute that.
Say that again. What?
Yeah, sorry. I said the Mage probe swings and rotates and so on. So I cannot say what the attitude was of Mage at the point of that image.
Do you know? Okay, so if you don't know at the point of this image, are there images within your Mage film that you do know when it's perfectly horizontal?
No, but that doesn't make any difference.
It doesn't.
Why should that make a difference?
Well, you're saying that the horizon doesn't rise to eye level or doesn't come up to this height. How do you know? You don't know where horizontal is. What are you basing that on?
I wasn't talking about Mage. I was talking about if you had a flat Earth, and if you have a flat plane Earth and you are above it. Well, actually, even stood, leave aside mountains and buildings and things like that. A flat surface, if you look directly forward, horizontally, then that land, although it appears to rise, will never cross the horizontal line of your eyesight. It can't. It physically can't. So the higher you are, the lower it's going to appear in your field of view. I think we're getting sort of sidetracked there a bit.
Well, really. Just let me respond to that because I'm not arguing that it rises to eye level. In my mind, that has nothing to do with this. I'm just looking at this image and what I see here. I don't know how far on a flat plane it would go. You can't see that far. You cannot see through those thick atmospherics.
Okay, and what I would say from that image is, if that was over a flat Earth, if you can move your with a mouse in the center at the peak of that apparent arch, why it does looking forward that bit look a further distance than to the left and the right of the image, which appear sort of lower down? That's what I'm saying.
Yeah,
it would be the same all around.
Well, how do you think this would look? You have a circle of sight. So when you look out, you can see the same distance in each direction. What do you think this would look like if you were inside here looking at the edge of this circle and took a picture? The edge would look like it is curved, right?
Sorry, I mean that's a sort of a thick ring. I'm not quite sure what you're saying
All
with
right.
that.
Let me put it this way. So here's our
I mean, I can imagine
circle of sight, okay? And
imagine a hula hoop.
yep. So this is from the top down. Yeah, it's like a hula hoop. This is from the top down, and we'll slant it this way so that we're looking down at the Earth. So there. Now this would look like a curve, right? If I'm standing in the middle of it.
The thing is, though, you're not stood in the.
Of course you are. You're always in the middle of your circle of sight.
You have to cut that image left to right, top.
But you're
yes, you are in your circle of sight. Yes, you are. But I mean, the image is actually both ways, isn't it? That you would be. You've got the center two markers just where your mouse was.
Yeah, let me go back.
You know the grab handles for the imagery.
Grab handles.
Yeah, you had that circle that you were just showing, that you were showing an angle. Excuse me, an angle. Oh, we know what we're talking about. In that, if you had yes, those are the grab handles. Yeah, you see, you've got the four corners and you've got top and bottom in the middle. Yeah, where you are now. So the one at the top is you looking forward. The one at the bottom would be the one behind you.
Yeah. You'd be standing like.
Take that image.
Here, let me make it a little bigger. And let me plop the man in there so we know what we're talking
in the middle.
about. Yeah. You'd be standing in the middle of this thing.
You take the top half of that image. Yeah, the top half of that image. Yeah, stood in the middle. Hey.
So I think naturally you're going to see some kind of curving effect due to this, especially when you're up at that distance. Although some people will get mad at me for not saying that the horizon is always a flat level line, but we can deal with that later. But I did want to go back to this. Does not?
I mean, whatever the cause is, Brandon. Whatever the cause is, that horizon, that edge, that changing color is not flat and level. Patently.
You're right. You are seeing some kind of curve here. Yeah, you're seeing a curve. Yeah.
Now, whether that's due to atmospheric effects that you're sort of postulating, or the curve of the physical Earth that I'm saying, there is curvature. Yeah, a curve. Sorry, I don't want. I mean, you just agreed that there is some form of curvature. Something is curving.
Not curvature of the Earth, but there is a circular effect taking place that you're seeing optically. Yeah.
There is a curve in the image.
There's a curve in the image, yes, clearly.
Okay, now what I'll do is I'll say thank you for that, Brandon, because that's not you conceding that the Earth is curved, but agreeing that there is a curve, a bend in that image. Thank you, because so many people have disingenuously looked at that and said it's straight.
Well, no, we can test that together right here. I don't know how you could look at that and say honestly, that it's straight. I really want to
thank you for that, Brandon.
Okay. All right, I don't know who I just threw under the bus, but you're welcome.
Different color. What color is that? What color is that?
It's green. Hold on. Green? Yeah,
yes. Yeah. That's better.
All right. So yeah, there is a curve to this, but obviously our assumptions about why that appears that way are completely different.
Yeah, but good on you, mate, for agreeing that there is we've made some progress here, and we both agree that there is something that is bent, curved, rounded, however you want to put it. And I'm not trying to trick you on that. I don't know if actually I will just read. I had a super chat. Let me just. I don't know if you've got any more. I did have another one to read out. I'll just refresh it in case.
Yeah. Go ahead. I got some too. Yeah.
Okay. Oh, I've got three to read out. Do you want to go first this time? Or?
Sure. Let me go here.
Yeah.
Flat Earth Data 699. Mr.Simple. What causes the apparent junction of the sky and the ground? Earth curvature of eyesight. As a question for you.
Well, if we're talking about, can you read that again? What causes the apparent
junction of the sky and the ground? Earth curvature or eyesight?
Earth curvature. Oh, did that make you choke?
No, fair enough. Yeah, of course.
Okay, yeah, Earth curvature. For instance, looking out over the ocean, that point where the sky and the ground, the surface of the water meet, the horizon is. You should try using globe technology. It works. Oh, he's gone.
Can you hear me now?
I can hear you, can't see you. So I'll tell you what. Shall I read my super chats out while you're sorting out? Right. I had one a little while ago from Remnant Art for $5 SGD. Sorry, I don't know what SGD is. It's the first time I've seen that. It's always amazing how these limits of vision and light always perfectly match what you would see on a globe. So I would have to agree with that. I guess you're not going to, Brandon, are you? I don't know if you can hear me. Oh, can you hear me?
I can hear you. Yeah.
Okay.
No, it makes perfect sense. You're dealing with the same variables at the same distances. Of course, you're going to have some visual effect as you look around you through a medium. Just like in the ocean when you go swimming. You can only see the sun so far down. You can only see so far around you. When there's a fog storm, you have visibility. This is not a new concept.
Well, so it's not a new concept to limits to vision due to the medium you're in, but Mage is not really in a medium, and why does that limit happen to look like a curve? But that's what we were discussing, wasn't it? I've had a super chat from Crafty Keeler. Thank you, Keeler, for €5 saying, can Brandon hear himself when he speaks? No disrespect intended, but this hurts to watch. Face palm. So sorry about that, Brandon.
No worries.
And one from Rob Montgomery for $5 US. Brandon claimed he has a model. Let us see it. Is that some discussion or argument there has been in sort of comments or sections or something? Or was that something that you said tonight?
Who was that?
A guy called Rob Montgomery.
I don't know. He must have picked up on a word I said. I don't know what he's talking about. I may have said on a flat plane model or something like that. No, I don't have a complete model. I can't show you a plastic thing. Here it is.
Okay. Can I ask you though? So what would be your view? It's a flat Earth, then, is it?
Yes.
Okay. Is it one? And again, this is just me questioning. I'm not trying to be disrespectful, but is it one that's sort of bounded by an ice wall or similar, or is it an infinite plane or something like that, or is it just unknown?
I don't know. Yeah, it's unknown in my opinion.
Do you think there's some form of container, dome for want of a better word, but some form of container over the Earth?
Some form of I don't know. No idea.
Okay. You've already said that. I believe you already said that there is atmospheric gradient.
Yes.
Yeah. And so, do you think that goes down to space? Is there such thing as space? This is just to get a feeling for where you're coming from, mate.
Space in the sense that there is less
in the sense as infinite
or...
vacuum going off where the stars, planets, and so on are.
I have no idea how far it goes. No, I don't know.
Okay. Well, fair enough. Thank you for answering.
Yeah.
Thank you for answering. I'm not quite sure where we. Oh, you were reading super chats as well, and you had some issues there. You read one or two, I think.
Yeah. Let me get back to that. RM Skillen. That is why flat Earth is such a joke to me. You dismiss evidence, and when asked for an alternative theory, all you say is, "I don't know." It looks like blackness. Thanks, RM Skillen. $10. Appreciate that. Brian Leakey. Ranty video, BBC program showing a PhD demonstrating line of sight signal from Birmingham BT Tower to London. I'll have to check that out, Brian.
I've come across that thing before a few years back. Yeah, have fun digging that up then, Brandon. See what you make of it. I won't try and colour your judgment on it.
And I had one more come in from the Plain Truth. Following flat Earth data, is the apparent junction horizon always the result of Earth curve, or could there be an alternative cause? I believe that's a question for you.
Yeah. Well, I mean, it depends on the topography of where you are. If you're in a hilly area, then that juncture is going to be the hillside. If you're in the middle of the ocean, then that's going to be literally going to be the curve of the Earth. where the ocean's curving round until you can't see beyond it, because just like anything else that's let's see if I can. You've got you can see that handle as it turns away, it gets hidden behind the curve. I mean, it's as simple as that. I'm not wishing to be disrespectful, but it really is a simple concept.
That's interesting that you say that. I don't think that anybody doesn't understand the concept, Mr. Sensible.
But then, okay, but then you get Occam's razor. Otherwise, you have to invent things like, well, how do you explain away, for instance, if that handle is a boat going over the curve, why is it always the bottom of the boat that disappears first? Then you get someone saying, well, it's perspective, but the masts on the ship are thinner and narrower, and yet you can still see those. So why is it I can't see the big fat bottom of the boat? That doesn't fit in with sort of laws of perspective. So you have to either hand wave it away or come up with magic or some other strange explanation. And yet, just hidden behind a curve fits it perfectly.
It is a pretty easy and convenient explanation that you're using there. However, I kind of think you're hand waving away atmospherics and the different effects that we see on the horizon, miraging. Obviously, you are limited or impacted by your line of sight to something as it what is it called? Dang it, compresses on the horizon.
Okay,
I think it's natural for the bottom of things to disappear. There's lots of reasons that could happen.
I could see I'd still disagree, but I can see what you're saying with small things, and obviously by definition, it's at a fair distance, so it's going to be hard to see. And then there are occasions when you get atmospherics interfering and mirages and that, and you end up with images like the Black Swan, but let's leave that aside. But what about something as obvious as either the sun or the moon setting or rising over the ocean, when you have the perfect circle of the moon or the sun, and then as it goes down, you end up with exactly half? That cannot be down to compression. It cannot compress one part of an object and not the other.
Well, that could be down to something else happening in the atmosphere.
But that's what I'm talking. Yes, something else. That's what I'm talking about. Hand waving.
No, that's not a hand wave. You don't know what's happening through that 6,000 miles of medium, right? Between you and the sun, 6,000 roughly. So when you so if
you're
the sun
a
is
local sunner, are you?
Yeah, I think yes, absolutely.
Man, no.
Well, I mean,
Brandon,
how can you think it's a flat plane and have the sun 93 million miles away? That wouldn't make any sense. So the sun has to be local in a flat.
Actually, I suppose
model.
it wouldn't. But so basically, I would say, if you're going to assume a flat Earth, then you have to have the sun local. So you ignore the evidence of the sun being 93 million miles away just to make it fit a flat Earth, because the evidence is it's 93 million miles away.
What evidence leads you to believe that it's 93 million miles away?
Well, how about the fact that an orbit round it takes a year, which matches? Orbital mechanics, that orbit of the Earth. I'm not into star signs and things like that, but they say, oh, you're in Gemini, you're in Aries or whatever, or the sun is in. That's because over the course of a year, as you rotate around, the sun apparently, or the planets, have different constellations behind them. It's absolutely meaningless in itself, but it takes that long for us to go round it.
Well, if you're not going around the sun, then how would the length of time that you supposedly go around the sun apply to a flat model where the sun, stars, and moon are circling above you? Why wouldn't it be possible for the same thing to happen on a flat plane? That what you just said, you'll try to apply the ball model to a flat plane.
Yeah, absolutely. I can tell you something absolutely impossible on a flat plane with regard to sun, moon, and stars. 2 stellar points of rotation in the night sky. In the north, you have the stars apparently rotating roughly around Polaris, but in the south, you have the stars rotating in the opposite direction, roughly around Sigma Octantis. How can you have 2 points of rotation in the sky, night sky.
Yeah, I don't know for sure about the 2 points of rotation, how that can be.
No one's been able to answer that,
I
Brendan.
can't say that would falsify some flat plane model of any kind. Perhaps there are 2 points of rotation above the flat plane. Maybe there's a point of rotation under Polaris. Maybe there's a point of rotation that's around Sigma Octantis. Maybe it's a visual effect from the stars in the middle. There are other possibilities. But there's too much other evidence to ignore.
Yeah, but this is evidence
for
ignore.
The southern stars.
Brandon, this sheet of paper is your night sky, okay? Where my finger is, that's Polaris. The stars rotate around it, okay? There's Sigma Octantis. How can it rotate around both points at the same time? It can't. I know that they're not a rigid sheet, but in effect they are, in that any stars do not change the gaps between themselves during the course of a night, and yet during a night in the south it's rotating one way, in the north it's rotating the other way on a single the stars have 2 points of rotation. That cannot work. It literally cannot work. Never mind about what shape the earth is. You can't have
It just can't work. You just can't wrap your head around how that could possibly be possible. I get it. And it seems like you're very stuck in this ball model mindset, which is fine. You're a globe earther. I get it. But what I'm saying is, I don't know what's happening with the stars. I really don't. And I agree that it fits your model. But I'm not going to rule out the other things that I see that tell me that we aren't living on a giant spinning ball.
If you had the stars and they were sort of in effect rotating in like gears, so that you would have 2 points of rotation, but then you see those two fingertips, they get further apart. That doesn't happen because in the night they stay the same distance apart, but in both directions. That's why it doesn't fit or work.
Yeah, I don't know about the stars. I'm not too big on the stars, to be honest with you.
Okay, but
I'm more worried about what I can touch and feel on the ground and see directly in front of me.
What I would suggest then is,
I don't need any suggestions, Mr. Sensible, about going to look at the stars, but thank you very much. Let's get back to the topic at hand, which I never finished my point.
Okay, I will.
So am I still sharing my screen?
Brandon, yes, you are, but I will say, for your sake, I'm saying, if you want to argue your case, I suggest you look into it more.
I didn't come here to talk about the stars, dude. You don't need to pull this, hey, daddy, let me sit on my lap and I'll tell you about the stars shit, or go look at the stars. I don't need advice from you, Mr. Sensible. Let's talk about the subject at hand, and then we can go our separate ways. So, if you look at this picture,
Brenda, because
this
we
does not look like I'm looking over. This picture right here that I'm showing on my screen does not look like I am looking at a ball and then looking at the edge. You'll see this area right here that comes up to about the top line. If you look on your picture, that area is very dark, but when you draw the colors out, you see that it is possible that this effect that's happening down here is also happening down here, and that this is a visual optical effect only that you're seeing. Furthermore, when I look at this land down here, This doesn't look like curve. It doesn't look like it curves off away from me. This looks like a flat plane going up out of vision.
Brandon, that's not land. Just turn the effect the other way again. That's all cloud, I believe.
Okay, whatever. So the clouds are going above the land,
No. You've just made a claim. You said that looks like flat land. I just asked you to turn it back. You said whatever. That's hand waving. Come on, man.
This doesn't look like curved clouds curving around a ball, if you want to be pedantic.
You're 30 foot. Go on, flick back to the cloud. So I'm not saying you were doing any deliberate manipulation to cheat. I'm not saying that, but just flick back to right. Okay. All you got is a lot of white and some bluish areas.
Yes, and that's why I changed the colors to draw it out, so you can see it in different colors. This one is interesting too. You have this effect in the middle, which appears to be from the sun. The sun is in this direction, and then you've got this darkness as you go out into the distance. Now this looks like there is more land behind that apparent blockage, or what you're calling the horizon there, that goes off into the distance. That's what it looks like to me. Now, can you falsify that that's what it is? That it is more land going off in the distance? Because your claim that it is Earth curvature doesn't sit with me, because when I look at it, I don't see Earth curvature. I just see the land going off into the distance, even more so when I draw these colors out.
Yeah, and if you turn those again, I am not saying that you were manipulating the colors. I'm not saying that. I appreciate you change colors. A lot of people do. They change the contrast or whatever to try and help. That's absolutely a valid thing to do. What I would say though is if you just flick between them, that sort of color change, darkish area towards the left is just just go back to the ordinary again and look back. Right, you said that. I mean, my color sight is not very good. You said there's a greenish area towards the left.
Yes, and you can see that in this picture. See how it's darker right here?
Yeah. So that's a greenish area. I don't know what that is. I don't know how the sunlight shade is lit, what that greenish tinge is. Is it thicker cloud below, thinner cloud below? I don't know. But you said that there's, under the ordinary conditions, there is a greenish area. So when you change the colors for valid reasons, you're going to affect the different colors differently. I do say,
that's the whole
I do
point
agree.
Of changing the
yes,
colors.
there is a darkish area. So, I'm sorry, say again.
That's the whole point of changing the colors, is to look at it in different lights and draw out different things that you couldn't see in the original color, right?
Absolutely. And I'm not knocking you for that. And I'm agreeing that there is a darker area over to the left, but it doesn't go out beyond what would be the curve. In effect, you've made the curve look tighter, haven't you? By doing that, it sort of brings the bright area towards you. You haven't managed to adjust the colors to bring out more details and then show stuff that's beyond the apparent bent curve, whatever we want to call it, that we can see in the unaltered image. There's nothing beyond that by changing the colors. You know, it's not like soldiers when they put on the night vision and they can see. You can't put a night vision filter on this and see something beyond that curve. You'll see nothing beyond that curve.
That's
you
right.
Won't be able to see
cannot
this land
see beyond this thick atmosphere right here. You just can't. So all I did was draw out the different colors that you actually can see it in here. Some more whiteness back here. But you've got to remember that when you get to that part of the horizon, it is so condensed as you get up here. Don't look at this yet. It is so
I mean, what you're showing there
here.
now, yeah, I agree. That would be what it would be if you were looking, well, perhaps as a cylinder, but yeah, over a curve. As you get closer and closer to the visual edge, then more and more of that surface is in effect going to be compressed. I'm not denying that. And yes, you'd be looking through more and more of the atmosphere.
So do you think you could see forever if it was a flat plane with all those atmospheric effects and the condensing into space of all of the atmospherics? Do you think you would be able to see forever on a flat plane?
Well, there will be a limit because, in effect, that compression's getting more and more and more. Absolutely, I agree. However, what you would end up with is that.
What would it look like? What would you have expected to see with Mage 2 if you had sent it up over
flat.
a flat plane? Yeah.
Okay, that's a good question. I would expect, well, we know we got an atmospheric gradient. So as we've got on there, you've got thick atmosphere and then fading through into black. I would expect to see that. So basically, I would expect to see exactly that image I've got there, but without any curve.
So you would expect to see this, but you wouldn't expect to see any curve, even though you've already acknowledged that the limit of our sight is a circle. We have a circle of sight. You would expect to see just like this, except you wouldn't expect to see a curve. Why not?
But if you're over a sphere, yes, you've got a circle because in effect, if you got your diagram with that little circle on, can you pull that up again?
Yeah.
Okay, because to the right of that sort of metallic-looking circle on the globe, you've got a cone. That, in effect, is what you're seeing with... Okay, I know it's accentuated just for the diagram, but that, in effect, is what you're doing with Mage. You're at the peak of that cone. You can see a certain distance, the same distance, 400 or 500 miles in every direction, but you've got a curve. If that's a flat plane, you will see, just like with a... looking with a hula hoop, you're going to see just a flat level surface because whichever direction you look, there's more flat. I would actually turn something round to you though, Brandon.
I
Do
really
you
wasn't
have-
satisfied by your answer to the question. Just so you know. So you
Well,
do
I wasn't
acknowledge that
satisfied with
if
you
go-
waving
if you
away
go
2
above
points of stellar
and
rotation.
circle
To
of
be
sight. If
fair.
you looked at your circle of sight and your vision was blocked at the limit of your sight, you acknowledge that it would look circular, and you acknowledge that you would expect to see something similar to this, but you have ruled out that this for the
No.
that
No,
it
you
is
miss-
a flat plane based on the Mage 2 imagery. What did
You
I
missed
miss?
my point. You just going back to that image with the little bloke stood in the middle.
Okay.
Yes, his vision is limited. Yes, we're not to scale, obviously. His vision is limited to that white circle because of well, he can see the same distance in every direction. He doesn't see a circle though. He stood in the middle. He can see, let's say, 25 miles in every direction. So whichever direction he looks, he can see 25 miles. He doesn't see a circle. He doesn't see a curve stood on the ground there.
Well, no, what he sees, the entirety of what he sees to the limit of his vision will be a circle that is around him. That is the circle of sight, right? We already agreed on this. You have a circle around you. That is the limit of your vision. If you can see 500 feet this way, you can see 500 feet that way. If I draw this, just like I have here, this is what it would look like from a ground position, where you would see a curve, which would represent the limit of your sight, and past here, the atmosphere would be too thick, or you just couldn't see that far.
Right.
Okay, so you do agree then that you would see a curve on a flat plane because of your circle of sight.
No.
Yes, you did. You just agreed that I was correct on this.
No, but I'm saying yes, you would see the same distance in every direction. Little red man there, if he turns around, wherever he looks, he'll see whatever distance it was you said, 25 miles for the sake of argument. A circle, if he's 6 foot tall, a circle around him, which there is, 25 miles radius, you think he's going to see it curve? It's going to be, he's got a hula hoop at eye level down a fraction of a millimeter. Is he going to see that it's a circle? No, he's not.
Why wouldn't he see the limit of his sight curving? Why wouldn't he see that barrier curve? If he looks in this direction, he's not going to see that taper off here, or he's going to see a taper off here. Is that what you're saying? That the circle of sight works in such that it always looks what? It would always look flat, or what?
You've been on a boat or a ship or something, I presume, at some point, or a ferry.
What's your point?
Yep. Yeah. No, I'm not mocking or whatever. But you've been on. Okay. So and it's you've been on one that's out of sight of land.
Yes.
Okay. Whichever direction you looked, I don't know what the distance was you could see, but whatever direction you looked, it was exactly the same. Did it look like a circle?
So that's what we talked about when we started the show, when I asked you if you were standing on the beach and looking out at the ocean, would you be able to see curvature? And you said, you'd probably have to have very good optics.
Yeah.
Now you're asking
absolutely.
me if I think I would see curvature standing on the ocean. No, I don't.
Yeah, but you're just saying that
36 kilometers, I would expect that circle of sight, since we have such a hard barrier and seeing such a far away to the point where the atmosphere is too thick to see beyond, that I would see a curve because of my circle of sight. Not the Earth curve, and it would look exactly like this.
So could you show me a photograph from being on a boat or something, not necessarily one you've taken, excuse me, a photograph on a boat? Surely all the flat earthers are saying it's flat, it's straight. We've not seen a photograph of a sea horizon where it's bent like that because of circle of sight, because it's bent towards you. It's the same distance wherever you look.
You seem to be contradicting yourself. I don't understand why you're saying it's the same distance wherever you look. I know that, but if you look in this direction, I look in this direction, right? This is where my focus is. Now, if I compare looking in this direction to here, this is going to appear as if it curves around me because my circle of sight is making a circle around me, like we already agreed about this, that you would see.
Hold on, go back to that image, though. Go back to that image. Let's say that center of the image is 500. Can we work just with 500 miles just for the sake of argument?
Sure.
Okay. How far is it to the horizon, for want of a better word, on the left?
Okay, let's. Yeah, that's another question. This one's in.
No.
Like
It's so where your mouse is there.
Yeah.
Oh, right. well, pick one of the other images, but okay, leaving aside that darker aspect to it, go to the right-hand end then. How far away is that? That's also 500 miles. It's the same distance away.
Of course, it's the same distance. That's how
Okay,
circles
so
work.
why do you expect it to appear like that?
Why do I expect a circle to look like a circle? That's what you're asking me. That why do I expect a circle to look like a circle when you're inside the circle?
Okay, let me try one more time. And I'm not being, again, I'm not
So
being
it's
rude.
the same distance here as it in here. You're saying if I put a giant circle on the ground and I was standing in the middle of it, just because it's the same distance here, here, and here, that I couldn't figure out that I'm in a fucking giant circle and there wouldn't be a curve to what I'm looking at?
It depends. If it was I don't know, in the middle of a soccer pitch, you have a centre circle. If you stood in the middle of that, you're going to see it's a circle. If it's 50 miles to the edge to that circle in front of him, no, you're not.
That's ridiculous.
You're
Why
not
would it
going to-
matter if it's the distance? I'm higher up so I can see further. Why does that change the situation?
Mage is higher up, but in a flat Earth, you'd see further because you're up higher, and it goes on forever. So,
All right, let's agree to disagree on this one.
maybe we'll have to.
But I'd like to ask you another question. Do you think we could use trigonometry to determine how far we can see in your Mage 2 imagery?
Well, I will. Quite honestly, I think I said before, I am not a mathematician. I'll have to defer to others who are on that. Okay, so I hope you can respect that. There's all sorts of information that can be gained from these images, like Walter Bislin gained. I mean, there's no way I could do what he did. No way at all. Absolutely stunning stuff he's done.
He does do a lot of work. I got to say, I'm impressed by how much he puts out. Does he have a team working with him, or is it just him?
I think it's just him. Have you looked at his Mage pages and calculations? Because if you haven't, Brendan, you have. Good, yeah.
Yeah, I based some of my calculations on his stuff. So I tried to calculate how far you were seeing in this imagery. Of course, the calculation is flawed from the get-go, since you have no idea at what point in your imagery, in your video, the camera is horizontal. So it's really hard to...
But horizontal doesn't matter.
It does matter.
No, hold on. I'll explain why it doesn't matter. If you take that rectangular image, the photo that's been taken, we know, or the manufacturers are able to tell us, where and how much distortion there is in different parts of that. Yes, if you've got an object across the middle, we know that there's no distortion. The further towards the edges, the more distortion.
No,
so
excuse me, I'm not talking about in regards to the distortion, Mr. Sensible. I'm talking about in regards to using geometry to figure out how far it is that you can see.
Oh, I see. Okay. Sorry, I misunderstood what you were talking about. I have had a couple of people saying they're quite right, that there is no physical limit to our sight, but I guess I do get what you're saying as well. Atmosphere does, because even on the clearest of days, if you're on a high mountain or whatever, everything starts to look bluer and bluer. So there is a limit to that point of view, but there's no limit, because we can see stars light years away. Andromeda Galaxy 2.2 million light years away, and so on.
Yeah, exactly. So what I did here is, we don't have to go through it because, like I said, it's flawed, was try to calculate how far you were seeing. I don't think this is 100% accurate, but what I did was take your field of view, which is 30 something point something, or 23.6. Is that right? Your field of view? Ignore this.
It's
26.6 vertical field of view for Mage 2.
I'll have to say I don't. I mean, Walter Bislin's got those figures because he looked up the manufacturer's details and he did some calculations or whatever. So, as I said, I am not a mathematician.
Okay, that's what you said the field of view was. So what I did was I based, called this center frame, right, in between these two lines here. So you're the center of your frame.
Can't do that.
No,
because they're not. Because they are roughly the center. But
this is a rough calculation. This is not brain science here. I'll just tell you what I did, and then you can tell me if you think I'm wrong or think about it. So what I did was I figured out where the center was, and I said, okay, Well, this is 13 degrees field of view from the center to the bottom and 13 to the top, roughly, right?
Okay, go on, carry on.
Okay. So then I using trigonometry, I figured out where this position is here at the bottom of the field of view, from the camera to this position, what the rough distance is. Do you agree that we could do that with trigonometry?
Yes, although you'll be looking at the top of clouds, but I take your point. Carry on.
Yeah. I don't know how high the clouds are. Maybe that would impact it. Good point. And then when you cut that in half, you would say that it's twice as far.
Are you working over a flat surface or over a curved surface?
I'm working over a flat surface. I just did this today, so I don't know if I'm flawed. I was hoping that you had an idea of how far you could see. But,
well, only based on signal reception of roughly 400 to 500 miles,
right?
Which equates with that cone that you'd see at the distance of 37 3/4 kilometers above a sphere.
So regardless of whether this is correct or not, which it isn't, let's just say this isn't correct. You're seeing a long way. As you can tell, when you get up towards the horizon, it is drastically compressing. So I would be surprised if it's only 400 models. Now, the ball model might tell you that it's only 400 models, but it'd be interesting if someone came up and calculated, based on what we see in this picture, exactly how far it is. But anyway, that's neither here nor there. So it sounds like we agree on nearly everything except for the fact that you are saying that you're 100% sure, it sounds like to me, that there's no way that it couldn't be Earth curvature in your Mage 2 imagery. Is that correct?
Okay, to be technically accurate and absolutely scrupulously honest, you always have to have that tiny element of doubt. So I'd say 99.99999, but I suppose there's that little chance. Being absolutely honest, I don't think for a moment that chance is the case, but you have to allow for that.
And I would agree with you. And I am not 100% certain, obviously, that it isn't Earth curve. Although I highly doubt it, and I would probably, bet a lot of money that it isn't Earth curvature.
Oh, can I ask you, Brandon? Because when I was talking to you, I'm not going into it again, but when I was talking to you earlier on about stars, you got a bit salty and said you weren't having me telling you. I wasn't trying to. I was saying, if you wanted to defend that position, perhaps you should look into that because maybe you could formulate your arguments better. That's where I was coming from. But what I was going to say was, oh God, it's slipped my mind now. Well, we've had a good discussion here, and it really. Oh yeah. What experiments have you done? I was trying to turn it around to this a little earlier. What experiments have you done, or could you imagine doing that might actually positively evidence a flat Earth?
Yeah, I think what needs to be done is a physical measurement of Earth curvature. Not using optics, not using lasers, taking as many variables as possible out of it, which would involve creating a physical straight line of some kind above the surface of water, still water, to measure the difference between the ends in the middle above the straight water. So you'd need like a 3-mile straight line, which is damn near impossible to do. You can't just go out in your backyard and do that.
Well, have you spoken or heard of Bev try thinking? Because that's basically what he's talking about, but using a water level.
Yeah, yep. Bev is on the show on a regular basis, and
what he doesn't seem to realize
for quite a while, but it is difficult to do.
Yeah, but he's gonna. If you had, let's say, you made, I don't know how, an absolutely rigid rod of steel or something that was 3 miles long that would not bend, and you put that above a flat, you know what I mean, a still surface of water, then in effect, what you're trying to do is draw a tangent line and have each end be further above the surface of the water than the middle. That would prove it's curved. If it was the same, that would prove it's flat. That's the sort of thing you're getting at, isn't it?
Yeah, exactly. Yeah.
Yeah. But what Bev seems to absolutely fail to understand is with a water level, if the water level here 10 centimeters above the ocean or whatever, then it will be 10 centimeters above.
Oh, you keep freezing up on me
because water. Am I back again now?
I think so. It's really choppy.
Gone, I think.
Keep going. That's fine.
Yeah. Tell me if I come back again.
Yep, I can hear you now.
Okay. What I was saying is, with Bev's thing, it's a malformed experiment Bev's talking about, because yes, the water will level. It will be perfectly level, but each end will be the same distance above the sea level because it shares the same gravimetric equipotential. It's like a glass of water will appear flat, so will those two ends of that level. He's not going to show anything.
Well, I think you should.
The laser experiment.
I would suggest that you talk to Bev about that. It's very.
Oh, I did, but he doesn't get that there's a difference between horizontal and level. I tried to tell him about that experiment. Was it Jeranism did with several boards of wood with holes in shining a light? Do you remember that one? Yeah,
that was a flawed experiment from the get-go.
If you've got three holes, you've got light that's shining straight. If it shone through hole 1, hole 2, why didn't it shine through hole 3?
Well, in theory, but what was he using? He was using a flashlight or...
I don't know.
Yeah, I just can't remember the specifics, but I remember watching it and going, yeah, I don't think that's going to work like how he's doing it. He had trees in the way and all this crap. It wasn't executed properly. I certainly wouldn't say his experiment falsified the globe. Otherwise, I know, or the flat Earth. Otherwise, I know you and a ton of other people would have ran out and done this experiment every weekend and said, "Hey, look, here it is. Here's the results."
I must admit, when you said it doesn't really show the flat Earth or whatever, but as Jeranism said, interesting.
Yeah, well, I know you guys love to harp on this one, but. He meant interesting interesting. I get it. But you got to understand, if you've heard his story of how that went down, they did chop his footage up. Now, whatever happened between them, I don't care, but I don't think it proves anything what happened to Jaron with those documentarians.
Well, I don't know who else might have been involved. I remember seeing bits of the experiment, but I do take your point that if someone else takes footage, you don't know quite how they've edited it together. So I do take that point. I've actually had a whole bunch of super chats come in while we've been talking. I don't know if you've got any to read, or should I read these first?
I think I've got a couple. Go ahead, and then why don't we call it a night after that? Before I do read, Brandon, I want to thank you. It's been a civil discussion, hasn't it? Yeah, for the most part. I got a little excited there, but you got to get a little excited every once in a while, right? So I apologize.
But excited is okay. Excited is okay. You weren't abusive, and nor was I. There's nothing like that. Excited's fine.
Good. No, I thought it was a good discussion. So I appreciate it. Thanks for inviting me over.
Well, this is a joint hosted, isn't it? So thanks for having me as well.
Yeah.
Okay. Right. So I'll read through these. Sorry if some of these are a bit salty towards you, Brandon. I'm sure you can stand up for yourself. Right. So PhD Tony, $5 Australian. There's a difference between hand waving and actual calculation. Mr. Glass Monster. And thank you for that, Tony. Mr. Glass Monster, $2 Canadian. Does Brandon Toy have a brain? Sorry. There's someone here called Far Q Tube. $2 US. A flat Earth model. That's crazy talk. Thank you for that, Far. Mike's 70. I've had a whole spate of these. Mike 71, $5 US. What does Brandon think about the pressure graph at the bottom of the Mage camera? Any thoughts on the pressure graph?
I don't talk about the pressure gradient argument in the atmosphere too much? Not really.
You don't dispute there's a gradient?
No, I mean, we can measure
No.
that there's different pressure at different altitudes, right?
Okay.
It's not
Good. Yeah, absolutely. Well, some people do dispute that sort of
I
thing.
dispute
but
what the cause is, but we can get into that another time.
Yeah, that would be a good one for atmospheric. Yeah, let's do that.
Yeah.
Let's do that another time. Okay. So yeah, Mike Brandon is not disputing that there's a pressure gradient. B-Ball for Life, a super chat $5 US. Brandon, are you saying that we can see all the way to the edge of a flat Earth in this picture?
No, I don't know how far we can see B-Ball. I think we can see a pretty dang long way in that footage, though.
Okay. And Steve 6464, $5 US. If your science does not support my narrative, then I make up new science to make me feel better. I think that's a little bit of a dig at you.
Well, I think that, science does do that. They come up with different hypotheses and then go out and try to falsify them or prove those hypotheses. So, yeah, I'm coming up with new fucking science. I don't like your science. Sorry.
Okay. B-Ball for Life again, $5 US. Brandon has already admitted that the flat Earth model doesn't work. I'm not privy to whatever that might have been.
Who was that?
B-Ball for Life.
Oh, B-Ball. Come on, man. I'll catch up with you later. Come on, that's not true.
Okay. Brian Pott Robson, super chat £5. Thank you, Brian. The notion of standing in the ring. Why do you not see the curve at lower levels? In fact, the curve should be more pronounced.
I'd like to hear his reasoning on that, but I don't think so. Maybe. I don't know. I'll have to think about that one.
Okay.
Yeah.
Fair enough. MC2. Good evening, MC. Thank you for joining us. Super chatted $4.99 US. Thank you. Quote, I don't want to talk about stars. Of course you don't, because it falsifies that Earth.
I really don't think it falsifies, but I do get your point, and I know why the Southern Star rotation, you could look at that and go, well, yeah, duh, it's another axis of rotation down there. But it's the weight of the other evidence, the other observations that I've seen that make me go, no, there is a possibility that something else is going on down there. And I think that possibility is better than the possibility that the other observations and evidence I have can be explained with the globe model.
And obviously, I would disagree, and I would say that at some point there's got to be some evidence that's an absolute killer for something. You say, well, actually, I can't argue with that. But for me, that is one of the killer ones. And for Mitchell for Australia, because he eventually said, after wriggling, he said, I don't have an explanation for that. But only got two more to read. The Snark, €5 said, Flurfer tactics. Keep talking so it sounds like you're winning. You have nothing, Brandon Toy. You have just lost. Deal with it.
Okay. All right. Well, that's like your opinion, man.
Fair enough. It's his opinion. And there's another one here from B-Ball for Life, $5. B-Ball's keen to super chat tonight. Lol. Oh, Brandon, you mean like how the main surveyor, Larry Scott, and George have already done? Does that mean?
No, not like that. No. Nowhere near like that.
Okay. I think that's up to date. I'll just have a quick check and then we can go on to super chats from your... I've got one more that's come in from Second Best Bob for £5. Thank you, Bob. I've been watching on Ranty's channel and haven't had my super chat read out over there. Also, the chat isn't that friendly. Smiley face with tears. Thank you for that, Bob.
Oh, sorry. I don't know what they did to you, Second Best Bob, but
okay. You go ahead, Brandon.
Sure thing. Let me see where I left off here. Okay. Second Best Bob, £5. How does Brandon feel about Ranty proving the globe over and over again? Obviously, I don't believe that ever happened. That's how I feel like it didn't happen. The plain truth, $4.99. I can demonstrate the aquatic horizon is the result of refraction every time. And if there's anybody that could demonstrate the effects of atmospherics Overwatered is the Plain Truth. He's got a lot of good stuff on his YouTube channel. Thanks, Plain Truth. Gently's channel, $2. Hey, Mr. S, you're slaying it. Brandon has no answers. Thanks, Gently. Just let me... Where's the block? But okay, blocked. Thanks, Gently. Rob
it's actually Brandon. Did you block him for that?
No, I didn't block.
Good. I mean, after all, not being funny, he paid you to say that.
Yes, he did. He paid me to insult myself. So
Yeah.
Rob Keane, well, I don't care. I mean, it's no big deal.
Nah.
Rob Keane, Cleary is the funniest guy on the plane. That's a bold claim, Rob. He's pretty funny, though. Flat Earth Data, what causes the ground to appear to rise? Your curvature calculator says it's the curve. In reality, it appears to rise because of perspective. Correct, Mr. Sensible?
Well, by definition, if you're on a sphere, leaving aside topography, any surface is curving down away from you. When you look forward, you're actually looking slightly down. I mean, we're talking about a big sphere. So it's as near as damn it horizontal, but you're actually looking just below horizontal. Read what he said again, because I think I've answered it. I'm not trying to avoid.
Yeah, let me read it one more time. What causes the ground to appear to rise? Your curvature calculator says it's the curve. In reality, it appears to rise because of perspective, correct?
No, eyeballs swivel. So when you're looking, you are looking subtly downwards. You're not aware of it. You're looking at a surface that's 20 miles away.
Okay.
It's not. I mean, there is perspective. Obviously, things are appearing smaller as they get further away from you.
Yeah, I think what he's talking about is it does appear to rise within your vision. I mean, due to perspective, things appear to ramp up to somewhere near eye level, especially when you're on the ground, right?
Absolutely. I'm glad you said that. Somewhere near eye level, it never ever goes above. Can't. Geometrically impossible.
Okay. Rakia Life, big super chat, $99.99. Thanks, Rakia.
Wow.
So still no measurement of drop from horizontal. I believe that's aimed at you, Mr. Sensible.
That is aimed at me. Like I said, I'm not a mathematician. Sorry, I didn't catch that person's name. Kia, was it?
Rakia Life.
Rakia. Well, listen, have a look at Walter Bislin's page, because he does do analysis on the Mage photos with both the Mage camera and I think the wide angle camera, and he does them at varying heights. But what he also does is, as part of that, he's worked out the horizon drop. Okay. So, I mean, you may disagree with what he says, absolutely, but he has done the maths. He's a mathematician, or has math skills that I don't. Okay. So I wasn't trying to prove any drop. I personally am unable to prove any drop. That's not what we were up there for. It was simply to go up there to try and take a photo of whatever's there, flat or curved. Okay.
All right. Well, thank you very much again. Thanks for doing this, and we'll have to get together sometime in the future.
Yeah, I like that. It was good, Brandon. So thank you very much.
Yep. Talk to you later.
Okay. Are you just going to drop out of the room?
Yeah, I'm just going to close the window and then talk to my guy.
because my OBS is linked to this window, so I can just carry on for a few minutes. That'd be great.
There you go. See you later. Okay. Wow. That was long, and holy crap, do I have to go to the bathroom. But I'm going to pop in the room in Discord if anybody wants to join me in there. And we can talk about everything that I did wrong during that debate. And maybe somebody will mention some things that I did right. We'll see. See how it went. I didn't think it went too bad myself. Okay, there's no one in there. If anybody wants to join me in general in the Discord server, you're more than welcome. I'm in there now, and we can talk in there. So I don't know, how do you guys think it went out there in chat? There was some stuff I know people were messaging me, Gleam specifically, I didn't get a chance to bring up. The conversation about the stars, I wasn't thrilled with what I said about this. I didn't want to go there to the stars, because I honestly do think that is a difficult thing to explain, is the second rotation, or apparent second rotation, of the southern celestial stars. And I'll be real honest, I don't know exactly why it looks like that. But like I said, just because I can't explain something in the stars, I'm not going to discount what I can touch, see, feel, measure and all of my life experience down here on the earth. I think that'd be a stupid thing to do. Yeah, I'll bring that up during the rest of the show, Gleam, that paper. Appreciate you sending that to me. Let's see who we got. Silent Zero, what's up, man? Oh, you there? You're on mute. We got Travis. What's going on, Travis? Can you guys hear me? Hello? Maybe I am even more screwed up than I thought here. Let's see here. Yeah, output device, input device. Can anybody hear me in the Discord?
Mic check, mic check.
Mic check.
Mic check. Can you guys hear me?
Brandon, I think you're muted though. No, you're muted.
Okay, can you hear me now?
Mic check, mic check. What's going on, Brandon?
What's
Into
up?
you on.
Now you can hear me, right? That's 2 days in a row I've screwed up by not hitting the mute. I'm getting like dumber as the week goes on.
Can anyone hear me?
Yeah, hey Matrix, what's going on?
Oh, Brandon, we hear you. Can you hear us?
I can.
You're good.
Awesome.
Yeah, we could hear you.
All right, so let's see who we got in here. We got Travis. What's going on, man?
Hello, what up?
Matrix Media J. What's up, man? Paid NASA Shill. What's up? Rakia Life. Hey, Rakia, thanks for that big super chat, man. I really appreciate that. It's awesome.
I got about 20 minutes. I'm headed to a dinner, and there'll be more flat earthers at this dinner than not. So it's pretty cool. And these are just people that I've met in business over the last year or two, and they were flat earthers before me, which is crazy. They didn't introduce me to flat earth, but we just found out that we were all flat earthers together. They're everywhere. Found some more last night or a couple nights ago at another gathering of men, and I was talking about sunrise or something, showing pictures, and the guy asked me if I was a flat earther, and I said yeah. He said he's been one for like 5 years. So.
Oh shit!
Kind of crazy. Yeah, I know. It's weird.
I haven't run into many flat earthers just randomly in real life.
You got to get out more and talk about it.
Yeah, I guess
because
so.
they're all around. Yeah.
Yeah, unless you bring it up, you're not really gonna know.
Right, they're not going to openly just wear a sign on. Most of them aren't going to wear anything on their shirt or hat. I mean, I don't. But I'm open. I tell everyone.
Well,
yeah,
more and more people are asking me.
Brandon, I think we are growing in numbers because this week new guys started working with me, and I find out that the dude's a flat earther. The dude, like, he's real woke, and it's like it was real refreshing to actually be able to work and have somebody to talk to about these things. So I think the message is getting out there. So I don't know where the globals are coming with this, that flat earth is dying. I mean, when have you seen the truth die?
Yeah, no, I don't listen to them. They do everything they can to make us think that we're in the wrong somehow. So, yeah, I don't think it's dying either. Now, they're not promoting us like they were because YouTube was making a lot of money off Flat Earth for a time period there, and then they got their hand slapped. So that gives the impression. But...
Hey, Brandon, about the south rotation of the star, always ask them to give you a 90-degree point of view of the rotation on the south. They don't have it. They cannot get you that.
What the hell are you asking for?
Oh, you're right. Yeah, they can't get they'll never give you a view rate under it.
Yeah,
I never looked into that too much, the Southern Star rotation. I suppose I should. I suppose he's right. I should look at the star rotation, but whatever. That was Silent Zero, and we got Bob Dole in the house. What's going on, Bob?
Hello. He was wrong, and you were wrong actually too for going along with it and agreeing with it. You don't have to allow for that tiny little minuscule infinitesimal percentage of doubt. You don't have to do that in a serious, legitimate, intelligent, logical conversation. You only have to do that if you're saying anything goes, anything is anything else, and we can say whatever we want. Whenever you're talking about using a logical, intelligent conversation that's actually going to go somewhere fruitful, you're only considering the things that you actually have verifiable, credible, repeatable evidence for. I don't have to consider the small, minute percentage chance that there's unicorns living under the ocean. I don't have to. I don't have to consider that at all until someone shows me something indicating that that's a thing.
Okay, fair enough. That's an interesting way to look at things, and I agree in normal conversation. I tell you what, you guys can talk about how the debate went or whatever else for a minute. I'll be right back, okay?
How can you account, Bob? How can you account for the unknown unknowns?
You don't have to account for the unknowns. That's the point. If you have to account for the unknowns, then anything is anything. Because anything it's always possible it's something else. You can say a rock is actually a giraffe because maybe it came from a different planet 1,000 years ago. Maybe they live forever. See, you can do whatever you want if you're not going to only base it on things that you can verify. Once you take that out of the equation, anything is anything and nothing is anything.
And what is actually verifiable about the flat Earth or the globe Earth?
Hey,
Things
Brandon, I
that are
just wanted to come in and say hello.
are verified in the only way that we can verify things. That involves you using the senses that we have in common to verify them. The same way, if somebody claims to you that they can levitate, you ask them to show you so you can verify it.
I see. And there's no such thing as optical illusions or anything, right?
It doesn't matter if there's such thing as optical illusions.
You always, because your eyes are extremely accurate precision instruments, right?
Yes, they absolutely are. 100%
No, they're not.
they are.
No, they're not.
No, but if you're doing
And in fact,
something
you have not
deceitful,
made
then
anything
it
better than
doesn't.
the eyes.
If you're doing something deceitful, it shouldn't be taken into account.
No, you don't have to take it into account.
Yeah, that's
the
what I'm saying
point.
to this guy.
That's the point, is you don't have to take into account things that you haven't verified. You don't have to even consider
Oh,
them.
you mean personally verified?
So would you say if a couple of years ago, like 7 years ago, so before Eric debate, right? Would you say it was logical to think that the Earth was flat? Would you think that that's the thing that people would say was logical?
Okay, that's two different questions. I think that people say a lot of things. So what people say, like, what are you asking me? People say lots of things. People say it's okay to murder babies. That doesn't make it logical. Lots of people say lots of things.
You mentioned earlier that talking about logic and stuff, and I'm just asking, like, I think flat earthers and globe earthers use logic incorrectly because we thought it was logical to live on a globe Earth. We thought that was logical because it was all the information we had. This is why I asked you about the unknown. How do you know that you're not basing
I don't think
decisions on
people do
something?
think it's logical. I don't think they think it's logical. I think that they don't consider logic. In a large percentage of their lives, they aren't considering the concept of logic. They're considering the concept of where's my next meal coming from? Where's my next dollar coming from? What's the next movie I'm watching? I don't think people consider the concept of logic in over 90% of their lives. I think you're wrong on that.
So outside of that whole thing, did anybody else have any observations about the debate? Anything that stuck out to them?
Other than the constant assuming the sphere.
Well, yeah.
It's not an assumption, guys.
They have to.
You have to use your precision eyeballs because your eyeballs are perfectly calibrated to measure big distances and small.
They work
angles.
perfectly for exactly what I try to use them for, which is seeing things. You haven't created anything better than my eyes for me to use to see things.
So you've never used binoculars and never used a telescope.
They're not better than my eyes because I couldn't use those with my eyes. They require my eyes, which means my eyes are better.
But they make your eyes better. They make your
No, they don't make my eyes better. They do not make my eyes better at all.
So using your P900. So how come all those pictures come with a P9000 that you zoom in?
Could they be magnifying the discrepancy with your eyes?
What I'm saying is, I suppose you don't wear glasses, right?
Oh no, I wear contacts. I absolutely do have corrective lenses.
So your eyes are perfect then, but you wear contacts?
Guess what? Those lenses are not better than my eye because they literally require my eye to operate. So my eyes
then why do you wear them?
I think he's referring to
the mechanism of his eyes, not the actual.
Guess what?
Scene.
Guess what? My
what is this conversation? What is this argument about? I don't get it.
Nothing.
Are you guys picking up from an earlier argument or something, or why are you guys arguing about?
He's trying to make the argument that man-made tools are somehow better than our eyes.
Yes.
They're not. It's literally impossible for them to be better than our eyes because we can't use them without our eyes.
Well, okay, let's
There's
hear.
not a single tool that can be used to verify something without the use of your senses.
Yeah, you have to use
And
your
with
eyes
the
either
car-
way.
Yeah, I was gonna say that. Without your eye, there's
Use
no
the tool
like
to begin with.
any. Yeah,
Okay,
without your eye.
using a tool to make your eyes better doesn't make your eyes better. So using the
It doesn't make
P9000
your
to
eyes
take a
better.
picture.
If
It doesn't
you
make
take
your
the
eyes
eyes
better.
away
Like
from
it
your
can
eyes,
help
your
you
eyes
So
to.
will
using
your
a
eyes.
P9000 to take a picture of a boat not going over the horizon. That's okay but I don't
It doesn't
understand
make
the
your
argument
eyes
here.
better.
Yeah, but that's not
Yeah,
making your eyes better,
I think
though.
the word
It makes
better
your
doesn't
better.
apply
You're
here.
wrong.
Maybe the word better doesn't apply here.
There's no such
doesn't.
thing as a P9000, by the way.
Oh, is it 900? Excuse me. It was a P1000. I'm not up to speed on this.
Obviously not, no.
Oh, it doesn't make a damn bit. It's a camera, right? It's got a lens on it.
Yeah. Could be distorting, couldn't
Brand-
it?
Okay, listen, we can make calculators that can do math really fast. Does that make them better than the human brain? Are calculators
Yeah,
better than
makes
all
them
human
faster.
brains in the whole world?
Hey,
No!
computers
It's
are
a
faster.
tool.
That calculator
No.
It's programmed to do what it's programmed to do. It has
Man.
Brandon, the debate went really well.
1% of the level of a
Oh, I
human
appreciate
brain.
that, Mark. Yeah,
But we
okay.
use it.
All right. What stuck out to you about the debate, Mark?
Well, he usually plays to his audience, and he uses a lot of mocking and patronizing language. But I felt that because he was in the middle, he was behaving himself. I saw a different side to him. There's a lot of flat earthers that give him lots of material that he can go off and do a video just on that specific point, whether it's a silly point or a good point. And he's got no comeback. But I saw a different side to him. I was quite impressed.
Yeah,
played him
appreciate
very
that.
well
I
as
felt
well.
like I didn't see a lot of that mockery. I was expecting more of that because when you watch his videos or you listen to him talk about flat earthers, he's very mocking. And there was a couple points in there where he kind of touched that, but I don't really feel like he ever turned that side of him on. He seemed pretty straightforward, and I feel like I had him on his heels at a couple different points during the conversation.
He was behaving himself, and he let things go that he would normally have pounced on. But I thought you handled him very well, and there was no personalities came into it. I thought it was very good.
Oh, good. Okay.
Is this the same guy in one breath said you can't see the curve from on Earth, and then in the very next breath he said you can see the curvature?
We could pick up loads of points that he was making, but I just felt that the conversation it was a cozy conversation.
Is this the same guy that said his balloon was up for nearly 3 hours and only landed 40 miles away when it should have landed 1,000 or more miles away?
No, 750 meters. I thought he said feet or meters away. That's it.
Meters. I mean, that
From where
there
I was standing, the
itself,
calculator went down.
that there
It was like
itself proves
like a few
that
miles.
That there itself proves the Earth is not rotating.
Yeah, I agree with you. You
No,
could
it
always
doesn't.
fall back on something like, oh, the wind's at 120,000 or some crap. You could always find an excuse for that, but I agree.
The atmosphere moves with the Earth.
The wind is not doing, I think in the UK we're doing allegedly 800 miles an hour. The wind is not doing 800 miles an hour, is it, to equalise?
No,
That's
but
very good.
you know what they say. What is it? Sorry, I keep cutting somebody off, but what is it? The where it keeps going? The
The atmosphere moves with the Earth.
Yeah, that whole thing. Yeah, that
And it's
They have
excuse.
got no, if it does, then they have got no Coriolis effect.
Oh yeah.
No, Coriolis effect is when you move. Standing still is not
What do you
Coriolis
mean when
effect.
you move? The balloon was freaking moving, weren't it?
No, not that much. It was moving up mostly. It wasn't moving north-south.
It was moving. You cannot
which
have
way?
something that doesn't
Which way?
affect one aspect but does in
Which-
another. You
No,
double speaking.
Nope, Coriolis is north-south, and it didn't move that far north-south, did it? It moved like
North
4
south.
miles.
So you only get it if you travel north to south.
That's correct. Actually, because that's what Coriolis is. It's conservation of momentum, pure and simple.
Did anybody
That
catch?
is complete and utter fucking nonsense.
I agree, Brian.
So you only get it on a merry-go-round, north-south, so you on a merry-go-round.
They fucking deluded.
Nope. Have you ever seen a
If the
hurricane?
plane takes off heading north, then it's got Coriolis. If it
That's correct.
turns, East or West?
God,
It's not Coriolis.
don't
You fucking
bring up a
idiot.
hurricane.
You're a
Really.
complete
or
nut.
drive
Don't go there.
any other object that moves that has nothing to do with East.
You're a fucking nut.
Oh, hey, let me ask a question.
No.
Did anybody
I'm
pick
not
up
that
on
you
the
are.
fact
You
that we
understand
can
it.
get back to that? We can get back to it. Did anybody pick up
No,
on the
no,
fact
let's
that
stay on this. He's a fucking nutcase.
No, I got you, Brian.
Not
Brian,
quite,
let's get back to it. We know that where this is going to go with the Coriolis. He's got his mind wrapped around that. So did you guys pick up on the fact that he? Hey, just wait, guys.
Lunatic.
Did anybody pick
No,
up
sir,
on
you
the
are. You
fact
don't
that
understand it.
if you guys keep talking over me, I'm going to have to mute you.
are a fucking moron.
Brian, chill out, man.
If you guys
No, I'm
keep
not.
talking
These
over
are
me,
bastards that are pushing this shit on us.
I know.
shit,
Let's
sir.
get away from the
Yes, it is
subject. We
fucking
know
shit.
what he's going to say, Brian. We know what he's
It's
going to
true. I'm
say.
not-
It's bullshit. We know
Brian.
what he's going to say.
You are a complete and utter fucking moron.
I know we've heard
Nope.
you. Listen, the only reason why I'm saying chill out is because Brandon is trying to address something. So just chill out.
These are
Let
the
Brandon.
people we need to fucking get out of here because that is the bullshit they're trying to reprogram us with.
Not bullshit, sir.
It is fucking bullshit, you lunatic.
Okay, guys.
Oh, nope.
Got it.
Snipers, cannons, everything.
Have no
Hurricanes.
effect on them, you fucking idiot. My mate
If you turn-
owns
All
a
right,
We're good. Hold on. Brian. I don't want to mute you. Stop. Okay, did anybody pick up on the contradiction that he made when I asked him at the beginning that he was standing on where he could see curvature from? If he was standing on the beach, would he be able to see curvature? How high would he have to go if he could see curvature? And then where he said you wouldn't see the circle of sight around you because you'd be on the ground. You couldn't see it on the ground.
I picked up on
Can you hear
that,
me?
and then in the next breath, he said you could.
Yeah, there was a few contradictions in there, but
These are all government fucking shills trying to reprogram us away from the truth. This is all bollocks. And that's
No, it's not bollocks, sir.
Obviously, you can
You're
hear
an idiot.
his voice. Listen to their voices. They have this monotone. They're reading a script.
Oh,
They've got
I am reading a script.
emotion
I
involved.
am a robot.
You are.
I am reading a
You
script.
are reading a script. You've got
Yes,
no
I am.
emotion in your voice.
Hang on a
I've
sec.
got zero
Can I jump in
emotion
here,
in my
please?
voice. I am sorry.
you're letting this guy get to you. Just ignore him.
No,
for
no,
now.
Brandon,
mate.
can I
I am
jump in
making
here, please?
everybody understand that these people are fucking government-paid shills to reprogram us. That's
No.
what they're all doing, and they've hit on everybody today. They've had a big fucking...
Oh, this is hilarious. Triggered much, sir?
No,
Because you don't understand Coriolis?
you don't fucking trigger me at all. I just
I
pity
didn't
you.
trigger you. Okay.
You are a
We know.
lying piece of shit.
Brian, we know that. We know who these people are. We keep this forum open so that it doesn't become an echo chamber and we hear outside ideas. Some of these people who come in, we're never going to change their mind. But it gives us a chance to argue against the arguments that they bring out there to people in the comment sections or on NASA videos or whatever. So they come here thinking they're going to reprogram us or make us look stupid. And we argue against them and show people the other. I'm sorry, what?
You are stupid.
And
Can
you're
I
fucking
come in
wrong,
here or
dude.
no?
Exactly what I'm saying.
Yeah.
That is
Can
what
I
they're here
please?
All
I
right,
would
he's
rather-
gone. So let's just continue.
Gosh.
Rob, I
I
think
just
you wanted to say
Wow,
something.
I cannot believe that.
Yeah, I just want to get a word into this paid NASA shill. Like, that's your name, and you're coming in here calling us stupid.
Yeah. I'm sorry about my outburst, but this is how passionate I am
No,
about
it's
this
okay.
subject.
Yeah, no, I hear you. I'm with you, bro. But I just wanted to have a chat with this paid NASA shill.
Don't.
Like, why would you even
don't-
make that your name? Like, why not make a fake name like Bob Dole? Like, you know what I mean? Like,
Whoa, whoa,
don't
whoa,
why
whoa,
paid
whoa.
NASA shill?
Drop it in reverse for
Rob,
I
thirst
love you.
here.
Whatever, man. I love the real Bob Dole, but you know what I mean?
Rob,
Like,
Rob,
why would you make
don't
your name
talk-
paid NASA shill?
Don't talk to
That's
them.
all I want to know.
Their idea is to reprogram, and you listen, just
Oh, no,
listen to
that's
their
not
tone.
happening.
They have this monotone. They just keep churning the same shit out every time you talk to them. It is a script they're reading from.
Yeah.
There is no passion in it.
Okay, I want to point out that claiming that their tools like cameras and things like that are better than our eyes is like claiming that bicycles are better than legs. Okay? Or that forks and knives are better than
Shout out to
hands.
Bob Dole.
Those things that you're using to actually use and put the tools to work, those things, they can't be outdone by the tools you craft with them. It doesn't make any sense. Bicycles aren't better than legs. You have to have the legs. Okay? The things that we create with our hands, they can't be better than our hands because the hands were required to make them in the first place. You're mentally handicapping yourself by thinking that way.
Exactly, mate.
Who was that arguing against you that, you know, your eyes weren't as good as tools or you needed tools? Was that the paid NASA shill?
Whoever he was
yeah.
Going bonkers on there, that same guy was, I'm pretty sure, the one who was claiming that our eyes are somehow worse than the tools we use with our eyes.
Oh, don't worry about him,
We
man.
put our eye up to the camera lens, do we not?
Didn't we design cameras based on how our eye works?
Yeah.
We literally have
he claimed that they make your eyes better. That was his specific claim. They make your eyes better. They don't make your eyes better.
It doesn't.
That's why I said earlier
Your
that
eyes are-
better is not the best word here.
That's nonsense. It really is. It's retardation. It's mentally like stopping yourself from using your brain to its full function by thinking that way.
Yeah, no doubt.
I'd like to hear his opinion on the Coriolis. I'd like to hear his explanation.
We know what he's going to say, though. I mean, we know exactly what this guy's going to say. And to be honest with you, he wouldn't shut the fuck up. Yeah, he's
you're probably right.
Already got him on my nerves. But if
I
you,
shouted him out. He got no answer.
He's just here to poke the bear. That's all he was here for.
yeah, let's talk about something else. So you guys seen anything good lately? Any good proofs today, or any interesting subjects that have come up? Did anybody watch the magnetic storm that happened last night?
Nope.
No.
Where was that?
I guess it was in the northern hemisphere, from what I understand. But somebody was telling me, oh, who was that? Of course, I don't remember. That they were saying you could see it from Australia, which I don't know how the hell that's possible.
Not from my backyard, man.
Hey, you didn't see anything? Okay.
I was outside.
If you account for lumen, then maybe it's possible to see it from.
Right? I mean, that just seems like that wouldn't work. But on a
you know how
flat
that
Earth, that
works.
seems like it would work, but not on their ball. I mean, I just wondered if
With
anybody
refraction, all is possible, Brandon.
Yeah, right. Let's see. I'm just looking through my topics here. Travis, you had some stuff, didn't you? You want to look at your pictures? Is he still there? No? Okay.
Hey, Brandon.
Yeah.
Did you get a chance to see what I sent you, that doctor there?
No, I didn't have a chance to watch it. What's up with that?
Oh, wow. This guy, I think he went before Congress or something, and he was pleading them to review the case. He found some drug. I forget the name, with a weird name. I don't want to mispronounce it.
I saw that essay. Yeah, it was good, wasn't it?
You saw that, bro? Yeah.
Yeah, man.
And apparently
Yeah.
this drug, it has track record. It's been proven, and it stops. Like, if you take it, you can't catch this virus
You
and
can't
the other
catch it.
viruses.
Yeah, you can't
Like,
catch it.
stunning stuff here.
Thank you.
Let me just pull this over so people can see it. Maybe I'll pop the link in, but here's what you're talking about. This. I can't keep doing this. Doctor pleads for review of data.
Yeah.
Yeah.
That's it.
Okay, this is worth watching then, huh? Cool. I'll have to check that out.
100%. Everybody should watch this.
Did you post it up somewhere, I see?
I just put it in the YouTube chat, and I'll pop the link in the general too, since I've got it in my thing here. Check that out. Okay. I can't play it because it's Fox News, and they'll strike me. But
Yeah, for sure. Yeah.
But
this guy, you should hear him, man. He's very convincing, and He says they've done many tests, they have information, and like it's proven, has a track record. Why not? He's just saying, look, just have a look at it. But they have their own agenda.
Yeah. Let's see.
It's on mainstream media, so be careful.
Yeah, no, I can't play it.
No, it will be part of their programming again, so just be careful. Anything on mainstream media.
Oh yeah, for sure.
Yeah, you
Well,
really
you know
do. Even stuff that looks like it supports us or goes against the establishment. They know how to steer people psychologically to give them what they want to manipulate them. They're very good at it.
You know what F, O, and X in gematria are, don't you?
Brandon, you should have checked my DMs, bro. I had to do
666.
Yep.
What's up, Jeremy? You were DMing me during the debate?
Yeah, bro, you should have checked my DMs, man. I was at work, but I stopped to take a little picture or something to show how you could see when you're seeing in the circle, like you said, how the farthest point away from you could appear to be higher. Look at the bottles in the picture I took.
Okay.
See how the middle one farthest away looks higher than the other ones?
Let me share it in the Discord so everybody can see it. Yeah, okay, so the top bottle is further away.
Yeah, nothing's curving. That's just perspective.
What do you mean? These bottles are all the same distance from you?
No, it's a curve. Like, pretend that's like your line of sight. From left to right, you're not seeing as far as you are straight ahead.
Yeah, but you'd be in the center. The radius in this picture, your position isn't the radius of this arc. So this is a tighter. If you completed this circle, I don't think it would go around you based on this picture, but
I'm just saying that's those bottles are just meant to represent the land you're seeing in front of you.
Oh, I see.
You know what I mean? And the land on the left isn't going to seem to be as high as the land in the middle due to perspective, because when you're above an object, things that are below you appear to rise up. But the one that's farthest away from you is going to rise up more than the ones on your left and right because they're not as far away from you. You know what I'm saying? In the 2D picture.
Yeah, I get what you're saying. Does anybody understand what his point was with that? Like, I've got this little diagram up. Let's say this is my position right here. He thinks that you wouldn't see, if you had a limit on your vision standing in the middle of a circle, that you wouldn't notice any curve from that limit of vision. I don't know how that could be. He says, yes, but they're all the same distance from you. So yes, they're all the same distance from me. I'm in the center. But obviously, the shape of the limit of vision curves. So why would I not see that? Why would I not see that? I'm trying to think what mechanism I could have brought up or what I could have said to get my position clear. Maybe he just didn't make his clear enough. I don't know.
How would you know it's same distance away?
I mean, do you think the bottles I set up didn't visually represent it well enough? Or?
Well, the problem is your bottles aren't, they don't make a circle where you're in the center of the circle.
Well, yeah, I mean, I did it in a small room, but I mean, essentially that's the gist of it. Like, you would see when you're looking straight ahead, you're going to see the point in front of you is going to be.
I understand what he's saying.
I do too.
I understand what he's saying.
It just clicked for me. I get it too. Because this is a circle, these ones are nearer to your position and would, okay. Perspective, they would change due to perspective because they're closer to your position, right?
Yeah, the ones on the right and the left are essentially would be closer to you because you're looking straight ahead. So the ones on the left and right would appear to be closer to you, so they wouldn't be as high.
But geometrically, they're the same distance. If it's a geometric shape, they would have to be physically the same distance. But according to perspective, what Jeremy is describing, it clicked right at the same time it did for you. Yeah, it makes sense what he's saying.
Yeah. Okay. my point is,
Now,
if you're standing in the center and you're looking this direction, these are all the same distance from you, so they'd look at all the same perspective level. But if you're focused in this area, I think these two would look different, and you would see some kind of curve to the limit of your vision. It would look like it curved around you, right? You're looking at a fucking circle. How could it not look like it curved? It wouldn't look like it's all the same distance, right? If you're looking in one direction.
Yeah, I think the problem with what we're discussing right now is we can't produce this in a scale that's adequate to demonstrate this. It would have to be a very, very large scale, in my opinion.
Yeah,
so
that's true.
Yeah.
I don't know, I thought my bottles demonstrated it, but if you guys don't see it, I guess not.
Well, yeah, but that's I think what Brandon. I'm driving, so I wasn't able to look at it, but I understood the concept. But if yeah, I mean, I guess I understand what you're saying. But in terms of so you can possibly reproduce the concept on a small scale like you did, Jeremy, and if you wanted to make your circle equidistant and have a radius, you can demonstrate. But in terms of demonstrating this on the Earth, I think it would be very difficult.
Like if you did make a full circle around you with my bottles, every time any one you looked at directly would make that one be higher, and the other ones around it would appear to be lower.
Yeah,
You know what
I mean, I get it. Yeah, I completely understand what you're laying out.
Yeah, like that's how you could potentially see a small curve. Like you said, we're looking at Earth; it's a much bigger. We can't scale it.
So, Jeremy, are you saying that if you focused on this one, which is where the focus is right now, these ones would look closer to you, but if you focused on this one, then these ones will look closer to you? Yeah, I think you might be right.
Yeah,
in
if you
a
did an
sense,
actual, like that's not even a circle around you. You know what I mean? I just set it up as like a piece of a circle, just so you could see. I only had so many bottles and shit. But if you were to do a whole circle around you, and they were all equal distance from you, any of those bottles you were looking directly at, the ones to the left or right of it, would appear to start dropping due to perspective.
Oh, someone's got the show playing through. Someone have the show open?
Remix!
Okay, cool. It's not open anymore. Yeah, that's interesting. No, I think this can be demonstrated, Travis. You could set it up on a smaller scale, at least the part of it that I'm thinking about.
I mean, yeah, if you had a tape measure and some objects that were all the same height and in a big enough area, you could go set a circle up around you, and you would see what my picture shows.
Yeah, again, to be clear, I'm not saying you cannot model it. It does make sense that you should be able to model this. So that's not what I'm critiquing.
You're saying the actual situation, we can't really set it up.
Right.
Yeah.
Yeah, I mean, I like it. So, yeah, it would be just like if someone, like whenever Andrew Thomas Young draws a diagram of what the rays are doing, I always say, show me that in real life. So you can model this out, and it makes sense conceptually.
Oh.
But now, if we were to go out into the world, right? If we were to go out into the world, where would we have to go to then see that the world does this?
Also, in his picture, sometimes we were looking at clouds. Sometimes we were looking at the ocean, it looked like. So you've got clouds that are 60,000 feet high, and the ocean, which is 0 feet high. So, we're not even looking at the actual Earth. You're looking at some points it's clouds, some points it's not. There could be different levels of clouds.
Yeah.
Yeah,
that's one thing I was trying to point out was on the left here, there's this is bluer over here. You can see it better here. Like this area is
Also,
darker for some reason. What?
yeah,
Why is that
also,
darker?
also with refraction, you're going to get, since the point you're looking at directly in front of you is farther away, you're going to get more refraction at that point. So it's going to loom more, just a little bit. And then the points on the sides are going to be refracting less, giving you the less refraction. No?
Brandon, go to the previous image again. Okay, now go back. Do it again, please. And then again. Yeah, so to me, in this image that you've got here, that ambient layer that is above the white. Okay, so I'll say the white is the Earth. Is it possible that ambient band, right? There's two of them. There's a yellow band, and there's a line through it, and then there's a band above it, and then you've got black, and then another band. Okay, is it possible that ambient band is farther land as well?
Yes.
Yeah, I think so.
I believe so. Especially if you look on the far left, it could extend land farther. You just can't tell.
What are these sticks in the foreground?
What?
Probably part of
these
Some
things?
shit on a balloon or something.
Those graphs at the bottom? Is that what you're talking about, Brian?
Oh, that's a graph, is it?
Yeah. He was talking about air pressure or something.
So I mean, just go back for yourself to the blue, and then just look and see. And okay, right. So if you see that turquoise line that goes across the middle that bisects the sky from the ground, apparently, right? I'm gonna say, okay, that's the horizon. I think that's the horizon, so that everything above that is the sky. But when you go to the next image, that now looks like, again, I'm going to say that's farther, that's land going farther into the distance, so that it was behind the medium.
Yeah, that's what I was trying to say during the debate too. And it just looks like a hard boundary because that's as far as you can see through this. That's a long way, that horizon. I called it a horizon. That blue band right there, that is a long way off. And you'll see the sun's right there. Notice the position of the sun is in front of us in this picture and to the right. Shining right down on here. And that's what's washing this out. This is where the sun is.
I did notice he stopped the video just where it had a little bit of curvature in it.
Oh, yeah.
Some of the shots showed it, concaved.
Yeah, I mean, he definitely chose particular shots and then said, well, I chose this one because this is how the distortion is or whatever. He had his reasons. But essentially what they boiled down to, it matches his globe model. That's why he chose those ones.
Yeah. Have we got his video?
Yeah, I got it somewhere. Let me see. 1 second, I'll bring it up.
It's obviously got a fisheye lens on it.
There we go. All right, so here's his Mage 2 results video.
Now, below the center line of the lens, you tend to get convexed, and above it, you get concaved.
There's the sun. You can see that created that light spot over there where it's all washed out. And it's darker in the back. That is one thing I noticed on this.
That's been cropped, mate.
So there... Has it?
Watch the cloud patterns change.
Right there, the sun is directly behind us. And we're looking... This would be, I think, north to northeast. Based on what time of day it is.
Run it slower.
And then you're going to turn around, and there's the sun in front of us. And you see the sun, where the sun is, creates this huge washed out area. We just can't see anything. Down there on the clouds or whatever the hell that is. So that's what you're seeing in that presentation that I showed you.
Bro, you did a good job. That was good. That was a good look for us.
Yeah, I hope so. Thanks, man. Gary Wybanga says, even though you can turn around and see in a 360-degree circle, you can only see 120 degrees at any time. Yeah, good point. I think I'm going to set up and do a demonstration on that perspective thing you're talking about, where they're all the same distance from you.
With my bottles, yeah, that's what I mean. All you need is a tape measure and just objects that are all the same height, and then you put the camera in the middle and just spin around, and you'll see how it works. If I had more time, I mean, I did it right in the middle of your debate, hoping that you would check your DMs and.
Yeah, no, I was too concentrated on the other stuff going on.
Yeah, no doubt.
Now, just to reiterate, I would disagree with Mr. Sensible when he said that if you do look at a 360-degree, if you were out in the ocean and you look in every direction, you're looking the same distance. I disagree with that.
Really?
Yeah, you're not looking the same distance. Go ahead, Travis.
Surely you cannot prove what distance you're looking at. The optics might change from one direction to the other.
No, I get that. I get that. But I've made this statement over and over again that if you have a team of people, if I put myself in the middle and then I orchestrate 10 boats to be around my axis, and we get as close to the horizon as we can with each of those boats, my hypothesis is that if you were to look down from above, each of those boats would be in a zigzag pattern. They would not be uniform in a concentric circle.
Because we've got no depth perception, have we?
But that goes back to what I was saying about the horizon being created by the medium. It'll bring it close. Like, Brandon, you saw those pictures I showed you, bro.
Yeah, oh yeah. Those are good. You want me to bring those up?
Yeah, if you want to, bring that tri-panel up. You've got 3 different distances there from the same observation point, same height.
There we go. Might be a little small on YouTube, but I'll zoom in on each one.
So basically,
yeah, Travis, hey, hang on. Can I say one thing?
Go ahead.
But Travis,
go ahead.
those are all the same direction. Like, if you turn 90 degrees on both.
Oh yeah, but I don't think we're okay. So I'm not saying I'm saying something different than you are. So we're not necessarily contradicting each other. My point is that the conditions of the medium are going to move the horizon farther back, closer to you, higher up, lower down. So that if I'm out on the ocean and I look one way, I could be seeing as far as 10 miles, but if I go the other way, I could see 20. It depends on what's going on in that direction. But the point that you're looking at here with these observations, the 2 images in the middle and the left are the same focal length. And what I do when I go to this spot to shoot is I try to get this channel marker to the very right of my frame as close as I can, because that is going to center that shot. So the image on the right is a shorter focal length, because if I would have zoomed in to the 357 millimeter, I wouldn't have had the channel marker in the frame. So that depth, that perception of depth is entirely, well, all three of them are, but that one should show you the entire field of view was caused, I guess, to recede, right? It like, it's like that, what was that trick that trick of the camera that Stanley Kubrick was well known for, where like the background drops away. Anyway. So you've got the image on the left, you can see the houses. You can see the houses. And then the image in the middle, you've got no houses. And in the image on the left, or on the right, it is dropped back so far that it compresses.
Wait a minute. Those houses disappeared bottom up. That must mean there's curvature.
Well, I disagree.
Okay. Gary says, how many degrees across was the snippet of the picture from Mr.Sensible? You know what, Gary? I have that somewhere. Because Walter Bislin has figured it out. I know diagonally it's like 59.1 or something. But I'll have to bring that up.
Hey, what's up, guys?
What's going on?
Hello?
Hey.
Yeah, I was just looking for a good opportunity to jump in. I wanted to, I would like to have a brief discussion about gas pressure.
Okay.
Yeah, I think it's something that we're all overlooking and is staring us right in the face. So first I want to start off by saying I'm pretty confident that the Earth is flat and stationary. But now this gas pressure thing, it's making my head hurt, and I need help. Okay, so here's how it starts. We go into the laboratory and we create gas pressure inside of a container. And then we look at nature and say, see, I told you so. But as far as I'm concerned, we're making a mistake, and that's not the way it works. Because technically, we're in a gradient. So I think it would be more responsible of us to go to the laboratory, tell you so. So how are we going to deal with this gas pressure situation? Because if we're completely enclosed, then
Have you ever seen a
in a
terrarium?
laboratory. Yes.
You can create a gradient.
I've seen a terrarium.
In a terrarium.
Well, it's easier
With
to
no
create
opening.
gradients with a container, so it's kind of impossible to create
but
one without one.
when we create the gradient, isn't there a pressure relief valve somewhere in there?
Maybe.
So now we're going to look at nature and say there must be an opening somewhere then, right? I mean, if that's the logic we're dealing with, then we got to commit to it. So it must be an opening somewhere.
Could be. I mean,
you're missing a very important point here. How do you get the
I'm listening.
gradient, the gas pressure, without it being contained somewhere?
No, I'm not saying we're not contained. What I'm saying is that if we are contained in a gradient, then there must be a pressure relief valve somewhere, because that's the only way for us.
They have terrariums. Sorry to cut you off, but they have terrariums that are sealed.
oh, that's easy. You can release by changing the shape. Like if I push on something like a table, it can change shape and break, and the pressure will dissipate. So with the atoms, molecules, whatever, if they change shape and compound into something else, that could lead to a release in pressure, freed up space, whatever.
Yeah, that's pretty much where I'm going at here. The only way for us here on Earth to recreate a gradient is with pressure relief. Is that not true?
That is not true. Have you seen that terrarium guy there? He has this bottle sealed. He only watered it once, and it's its own echo, like its own what do you want to call it, system. You ever seen that? The big glass bottle?
No, I haven't. So basically, you're saying we can recreate a gradient in a sealed container?
It has been done, yes. A whole system. There's water, there's plants, it recycles itself. You never seen that? Google it, YouTube it.
No, I'm definitely on it. So now, the other part of this conversation was dealing with the double slit experiment. Now, if we've accepted that as a part of our reality, doesn't that kind of like compromise our conclusions when we observe and control a thing?
What do you mean compromise? How does it compromise? What point are you trying to make?
Hang on. The important part about that is that light's not a wave.
Yeah, well, that's pretty much where I'm going at with this. If we have accepted the double,
you went from terrarium to this. Is there some logical?
It's a reason. It's a reason why I went to the double slit. It's a reason why because if I take a cup of water up to the top of a mountain, it's going to boil, right? I mean, it will evaporate. Is that not true? If I take a cup of water up high into the atmosphere, it boils.
Okay. What do you mean it boils? So what's your main point? Kind of tie all this together again?
Okay, listen, hold on, guys. Listen.
Yeah. So
its boiling point will be lower. It won't boil.
Oh, he's talking about a low pressure, like a vacuum when water appears to
Eventually
boil.
it
Is
will,
this what
yeah.
you're saying? Okay,
right. So if we take a cup of water up really high, it boils, right?
No, it does not boil. It will boil.
It appears to boil. It outgasses.
Right. Okay. You know what? You're right. It doesn't boil. It doesn't boil. The word is transition. It transitions. Okay. Is that the word? Is that the word? Is that the word we can use and agree to? Can we agree to use the word transition?
The word is boil.
Yeah, we get what you mean, yes.
Okay, so if I take a cup of water up high, really, really high, it transitions right in front of our faces. So how can we recreate a gradient? So how can we recreate a gradient that does that?
In a container.
So we can also do that in a container?
In a vacuum. In a contained vacuum.
In a contained vacuum. No. What I'm asking is, can we mimic what we believe nature is doing here on Earth? In other words, gas pressure. We can.
Yeah. If you put something in a vacuum, it'll begin to quote unquote boil off in a similar way.
Lemon bird.
No, that's not what I'm asking. That's not what I'm asking you,
liquid,
brother.
It will start to quote unquote boil off similarly.
Are you suggesting
that's not what I'm asking you, brother.
Hold on, guys. We got too many people.
I'm trying to get a better understanding. I'm trying to get a better understanding because this stuff I've been tossing around in my mind for weeks, and like I said earlier, I said I need some help from you guys to help me, get my thoughts together dealing with gas pressure and stuff like that. That's why I'm reaching out to y'all to help me understand.
Sheep and wolves clothing. That's what I think. I think you have an angle here.
No, I don't. Look, I'm individual. I've been a follower of Ranty, Nathan Oakley, and Flat Earth content for years. Okay? So I'm not a wolf in sheep's clothing. I'm not a glober. All
right, let's just take him at face value. Let's take him at face value and let one person answer his question calmly. Travis, you seem like you want to take a shot at it. Go ahead.
Well, yeah. The only thing that there's a couple things. First of all, I'm taking you at face value. What's your name, by the way?
Individual.
Okay, individual. So I'm not getting anything on my radar the way SE is, so I'm not coming against you that way. The second thing is I really appreciate your questions, and we got a lot of people talking over you. So everybody on the panel, if we could possibly please, if you hear someone talking, just stop talking. The last thing to correct what I think Lemon didn't get is that you're asking, can we not only reproduce a terrarium style gradient, but within that terrarium have the same kind of effect that if we took a glass of water high enough, we would see it transition.
Yes.
Okay.
That is exactly what I'm asking.
Okay, great. So Lemon, that's why your go-to vacuum didn't work. Okay, that wasn't addressing his question. I'm done.
Well, the thing is, to address that question, we would need an Earth-sized container to fully reproduce it. Now, if you want it reproduced on a smaller scale, I don't know if that's possible, but we can reproduce part of it with the boiling off in a vacuum-like condition or a condition that's going toward the vacuum, toward more vacuum with more boiling. That's about all that we can reproduce as far as I can tell. But if
that's
where that I don't know about that.
That would definitely.
Well, that's pretty much why I brought up the double slit
My O2
experiment.
sensor doesn't want to go in. No, I probably hung him up. I just left the truck go back there.
Rob, your mic's open.
Hello?
Yeah, sorry about that. I think
Yeah,
Rob's mic was open.
that's pretty much why I brought up the double slit experiment, because I'm starting to believe that in a laboratory under our control and observation, gas pressure behaves a certain kind of way, but then nature, something else is going on. There's another explanation. That's where I'm going at with this.
How so? Elaborate.
Okay. Okay, so we go into a laboratory, we get a CO2 cartridge or whatever, and we force gas pressure into it. And we know that a container is needed to generate gas pressure. No argument there. But then when we look at nature and we see the gradient, it's like the only way, well, previously I believed that the only way for us to create a gradient was with a pressure relief valve. But just moments ago, the brother informed me that we can create a gradient with a completely sealed container. Now, I didn't know that. But even now that I know that, I still look at nature and I see...
When you put gas in a container, does it turn liquid?
No.
Let's say when you get barbecue gas, right? When you put it in the container, what happens to it when you start squeezing it?
Well, you mean what do they call that stuff? Propane. Yeah, the propane is a liquid inside of there. You're right.
Exactly. So do you not have a gradient in there?
Inside
liquid
of
on the bottom and gas on top?
Yeah, well,
Is that not a gradient?
the propane tank has pressure. Yes, it is. And the propane tank also has pressure relief.
Yes.
So is that the logic that we're going to use? So if that's the logic we're going with, we're committed to saying that there's an opening somewhere and that there must be some pressure relief here in our Earth. Right?
I see where you're going with that. We can say it either way. We don't
because
know.
I mean, we can't. Right? Yeah, because I'm saying I think it's haphazard.
But I see where you're going with this. Yes.
Yeah, because it's haphazard for us to just create evenly distributed gas pressure inside of a container and then look at Earth and say, see, I told you so, because that's not what we're dealing with. We're dealing with the gradient where if you take a cup of water up high enough, it transitions. So there's another explanation as to what's going on with our gas pressure. We know that our gas pressure is not pressing off of any walls. We know that because it's a gradient.
No, incorrect.
Now, I'm not
that's where
you need to have
you
a
just blew it
container.
right there, but
Why do you say it's not
against the laws? Against the laws of
Well,
physics.
I can't hear two people speaking at the same time. Can one of you guys go one at a time?
Well, I just wanted a clarifying question. Why are you saying we couldn't have a gas pressure gradient? I forgot what you said. Without
pressure relief.
No, you said something about walls with wall. What was it you said?
Yeah, well, we're in a gradient, so we know that our gas pressure is not pressing off of any walls, right?
Why do you say
That's
that?
the mistake you made.
I don't understand why you're saying that. Walls, you mean on the sides of us? Or do you mean walls and a ceiling? What are you saying?
Well, I mean, I'm saying because it's a gradient, I don't believe that our gas pressure is evenly distributed in Earth. It's a gradient, so we're not pressing off of any walls, are we?
What is that one? What does one have to do with the other? Whether there's walls or not, and there being a gradient. Why are the two connected? Maybe I don't understand.
How do you have pressure without containing?
Okay,
hold on. Let me answer.
I'll answer that.
Yeah.
Okay, well, the reason why I'm pretty confident that our gas pressure isn't pressing off of any walls is because if it was, wouldn't our gas pressure be evenly distributed throughout Earth?
That's a fantastic point.
Why would it be? Why would adding some walls around it?
I've ever freaking heard, man.
Hold on. Why would adding some walls around it make it evenly distributed? Why would having no walls mean it's not evenly distributed? I don't.
Right. Okay. Good question, and I'm going to answer that because, like, on ground level, right? I guess we can all agree that it's on ground level that gas pressure is being created. Can we agree?
The gas pressure is being
created.
created.
The gases are created there.
Yeah, the gas.
Not the
gas.
Yeah,
good point.
The gas pressure is being created at ground level. Trees,
Negative.
grass,
I repeat, negative. Wax in your ears.
Okay.
The
where's the gas pressure?
Created in the ground level, not the gas pressure. Do you understand the the difference between that?
Well, I didn't hear you. Can you please repeat that?
Sure. Not the gas pressure is created at ground level. The gas is created at ground level. Do you understand the difference between that?
Not exactly. Can you please elaborate?
I'll explain it to you. The gases are coming from the rocks and from the earth. Now, in order for those gases to create pressure, they have to be pressing on something. In other words, PSI, pounds per square inch. Do you understand that?
Yes.
There you go.
Okay, so
what's the confusion here?
Wait. So the gas is being produced at ground level, but the pressure itself is being caused by what now?
Container.
You don't know. Hold on, guys. You do not know how gas pressure is produced?
Well, I believe that the gas pressure is coming from the trees and the grass and stuff like that. Don't they? They spit out gas.
So you didn't hear what I said before. Yes, the gases are produced.
It sounded like you said the gas was coming out of the rocks, but
Again, you didn't hear. All the things that we mentioned, the ground, volcanoes, whatever, all the gases are produced at ground level. Do you understand this?
Yes.
But in order for the gases to have gas pressure, they have to be contained. They have to be pressing against something. Hence the term PSI, pounds per square inch.
Interesting. Well, that's what leads me. Yeah, that's what leads me to my next point, because now that we agree that the gas is being produced at ground, and in order for the gas to build up pressure, there has to be walls. So how do we manage to maintain a gradient without pressure relief?
Why do you think that there wouldn't be, just because there's walls, why would you think there wouldn't be a gradient?
Yeah, because he's a baller. I called it from the beginning.
Guys, hold on a second.
You're cutting out.
If we're enclosed, if it's completely enclosed and gas is being produced at ground level, wouldn't the PSI continue to go up until the gas pressure is evenly distributed?
Unless it's in a cycle, and also there could be valves. I mean,
right. That's why I'm saying there some type of cycle, some type of pressure relief. If there's no pressure relief, but the gas is constantly being produced, then it wouldn't stay at 14.7 psi. It would continue to increase until it's evenly distributed. Is that not right?
That's not right.
Unless it's like rain and it gets recycled the same way rain does over and over and over and over again infinitely.
We're in a dynamic system. There's all kinds of systems mixing up, churning everything.
The gas is produced at ground level, but it's also consumed at ground level.
Does high pressure
It's consumed. So it's consumed at ground level.
That's kind of like thinking that our world would flood.
Let me just get this out.
Well, if it's consumed at ground level, that's our pressure relief. So how is the gas pressure consumed at ground level? Now you see we're getting somewhere. I'm learning something now. Thank you.
Because there's cycles to the gas. The gas comes out of the ground, and the ground also uses the gas.
Are you breathing gas right now?
Then what's the point of the walls?
To keep the gas
PSI, Kosho. PSI.
So the pressure should be acting against the walls of the container, right? But it's not. You just said it's acting against the ground.
What are you talking about, man?
Welcome, Kosho.
Now that just made this more confusing. So the gas,
Don't listen to Kosho.
the gas is not coming out of the ground, bro. Gas is being produced by trees. It's being produced by the trees and the grass.
Have you noticed the same walls?
Most of the gas. Hold on, Lemon. Most of the gas comes out of
It's being produced by cows. It's being produced by chickens. Do you want to go over it again? Do you not understand?
Most of the gas.
You
Guys,
have seen a geyser up out of a pond or a lake, surely.
Most of the gas.
All right, let Jeremy have a shot. Go ahead, Jeremy.
Most of the gas comes out of the ocean. That's why the ocean level determines the 14.7 psi. It doesn't matter if you're on Colorado on a Rocky Mountain. Most of the gas comes out of the ocean.
Okay, who am I speaking to right now?
The bloke underneath you, Jeremy.
Jeremy? So you said the gas comes out of the ocean, right?
Most of it, yes. But there's other places that come from volcanoes.
So where do we get our pressure relief to maintain 14.7? Why isn't it constantly increasing? I hear you.
Why do you think we have to have a pressure relief? This is where I'm losing you at.
Well, the reason why I think we have to have pressure relief is because the only way that we, as human beings, can recreate a gradient is with some type of pressure relief, right?
No, I told you there's terrariums, sealed, closed system terrariums that have a gas pressure gradient inside of them. There's no pressure relief.
He doesn't listen very well.
Yeah. Okay. So.
I'm definitely listening.
Yeah, I believe.
I'm definitely listening.
Go ahead, Travis.
Yeah, so that's what I was going to say is where Jeremy just took us. In the terrarium, where you have a sealed environment, you don't have this pressure building up so that it pops or explodes. The system is an ecosystem. It balances itself out. So the pressure release that you're looking for is us, is the ocean, is the clouds, are the trees. Is the sun.
Consumption.
It's a dynamic system, dude.
It's balanced.
Let me ask him a question now. If this release valve was there, like you're saying, right? And we're next to a vacuum of space, right? Wouldn't all the air
No. We're not dealing with outer space, bro. I told you. I do not believe in the globe. I do not. I'm just trying to get a better understanding as to how our gas pressure is maintaining 14.7 in a gradient, and it's it's like I think it's weird for us to go into a laboratory. We go into the
hang on
laboratory. We go.
Who said it's 14.7?
It's 14.7 at ground level.
At ground level, at sea
it's
level.
a gradient.
Prove it's 14.7.
Right. I'm just saying, we go into the laboratory, we recreate gas pressure, and then we look at nature and say, see, I told you so. And then on the other hand, we accept the double slit as a part of reality.
Hey, that's what I'm saying. I believe. Explain.
Yeah,
why.
Because I think it's contradictory.
Prove it.
Quantum physics.
7 psi.
I think it's contradictory. Say, please repeat that.
Prove it's 14.7 psi.
You said prove it's 14.7?
Yes.
Well, in order for me to do that, I would need a barometer, and I don't have one, brother. So, I mean, if your argument is that That
Okay, hold on.
it's not
Hold on, hear the rest of
14.7. I can't prove it to you.
hear the rest of the argument. High pressure always goes to low pressure, correct?
Yes.
What pressure do your tears come out at?
My tears?
Your urine?
From a higher pressure from a higher pressure to a lower pressure.
You think you fart at over 14.7 psi? Do you
Can you
think
please
a
repeat
woman
that?
has a
Someone else.
menstrual cycle? Do you think a woman has a menstrual cycle over 14.7 psi?
Yes.
Don't be
Yes,
fucking
she would.
ludicrous. No, they don't.
Well, she would have
He's
to, right?
confusing gauge pressure and the
No, they
actual
do
pressure.
not.
Yeah.
Because any woman will tell you if they get in a bath of 5 or 6 inches deep, they stop. Now, there is only millibars at that pressure. We are not in 14.7. It is a complete load of nonsense.
Yeah. So whenever they use pressures like the body, they're adding that.
So we're not at 14.
No, they are
No,
not.
no, we are at 14.7.
You're trying to take 15 psi. Absolutely fucking ludicrous.
Well,
don't get why
in the
you're-
current
Why are you
conception,
fighting
you
them?
kind of equalize out with the system. Like they'll take an octopus from low in the ocean and bring it up really quickly, and it'll just like explode. It'll just basically go from inside out if it decompresses really quickly. So basically, on a theoretical level, they say that there's more pressure down there. Its body basically is used to pushing out at a certain pressure, and if you bring it up really fast, it's not used to pressing out at that lower rate or something.
But what does gas have
And that
to do
happens
with
to
the
us
double
when we get
slit?
to bend.
The double slit is light. What does this have to do with the gas?
Yeah, that's what I was going to say.
Well, the reason why I brought up
obviously
no, the reason why I brought up the double slit. Yeah, the reason why I brought up the double slit is because in a laboratory, gas pressure behaves the way we would expect it to. You know, but then when I look at nature, I see something else going on that may be connected to the double slit. I'm just trying to get a better understanding.
I mean,
How do you
could be
equate the
something
double
weird going
slit
on.
with that?
You know, because
Okay,
we can't.
That's the fifth time he brought that up. He has to explain it.
Let me jump in just real quick.
Yeah. It makes perfect sense to me that when we go into a laboratory, and we do experiments, these things behave the way we would expect them to under our control and under our observation. However, nature is doing something else when we're not looking. You know, when we're not looking, when we can't see it, nature is doing something else. So our gas pressure.
What are you talking about?
Okay,
Nature's
I think I
built-in,
know.
release
Listen,
valve.
I think I get it. Listen, hold on. Okay, so this is
I think
what
you
I
guys
hear
should
him.
stop attacking him.
Yeah, I
Calm
do
down.
too. I do too.
Settle down, guys.
Double slit experiment got to
Brian,
do with gas pressure.
Brian.
Go ahead,
listen,
Travis.
Okay, here's where. Okay, he's for lack of a better term, he's mixing metaphors. Okay, on the one hand, talking about gas pressure, he's saying just because we can go into the laboratory and produce something that we think mimics nature doesn't mean it's the same thing. So then he says, okay, if we can question that, okay, now let's do the same thing with the double slit. Just because we can reproduce something with the double slit and see something and control those variables doesn't mean that that's what's happening in nature. Nature's doing something else. So he's trying to challenge the mainstream narrative. Even though you can do this in the laboratory, doesn't mean you are reproducing what nature is doing.
Right. That's exactly what I'm saying. That's
Very
exactly
well
what
could
I'm
be because
saying, bro.
They've used some pretty big objects in the double slit experiment. So I mean, something weird could be going on with the gas. But what's the point?
That's the only point that I'm trying to make. Well, the reason you said what's the point? The point is, I think, like as flat earthers, I like to think that we're on the intelligent side of humanity, and I think it's irresponsible of us to go into. I think it's irresponsible for us to just say a container is needed for gas pressure, case closed, move on. You know, I mean, if that's the logic we're going to use, then we would have to stick to that logic and say, well, to make a gradient, there's other variables.
But
So
to have a
if
gradient,
we-
you have
I
to have
don't buy
one
it. I
layer.
don't buy it. Hold on. You
So-
said that you don't need containment to have gas pressure, right?
You are
Is that what you said before?
No, in order for us
You said
to
that.
have gas pressure, yes, we need a container to recreate gas pressure. No argument there. But when I look at nature, I'm not saying we're not in a container. I'm just saying I see something else, and I'm having a hard time understanding what's going on, which is why I'm reaching out to you, brothers, hoping that you can help me get a better understanding.
Well, the
What do
thing
you
is,
see? What do you
Is it
see
the
that's
gradient you're
hold
struggling
on,
with?
guys. Wait, just a second. In the Bible, the heavens opened and closed like there was some sort of opening and closing, maybe to the firmament or whatever. So there may be a way to open and or close and let out pressure potentially anyway. But with the double slit on the second thing that you were talking about, the double slit has several interpretations. Wave-like interpretations, particle-like interpretations. There's multiple ways to even interpret that experiment. In general,
Right.
if you have one layer pressing against another, it's going to press against another layer, press against another layer, press against another layer, ad infinitum until it stops pressing against something. That would typically be a container.
Negative. That cannot happen.
There would need to be a container to stop the pressing.
Hang on,
Yeah,
the gradient. Let me try and maybe this is how it works. I don't know. The gradient can be the pressure relief. Okay, the gas is produced at ground level. It's also consumed at ground level. That's why it's most
What's
dense down
consuming
here.
it?
As we go up,
What's consuming it?
Plants, the
We all are. Everything is. It's a cycle.
Humans,
So as we go up,
animals.
hang on. Yeah. Okay. So as we go up, we
Don't
get
we
further
also
away from the
produce
Earth.
gas
Hang on.
ourselves?
Can I just?
Yes,
can I
and the
finish,
trees
man?
consume it. Don't you understand
Yeah.
that dynamic system?
All right, go ahead,
Let me
Effie
talk
Evangelist.
it
Go ahead, let him talk, guys,
Jeez.
please.
Just fucking shoot me down at the end, not in the middle. So, it's all produced at the ground. It's also consumed at the ground. The further up you go, the further away you get from the production. It gets less and less until there's almost nothing at the top. So, let's just pretend 10 cubic meters gets produced at the ground today, but whatever's alive on the Earth today only uses 9 cubic meters. Well, as we go up, there's less pressure. Therefore, the excess produced at ground level can expand into the lower pressure area above it. And then the day after, we produce 10, but what's on the Earth consumes 11. So then the gradient comes back down a bit. I don't think it's like that gradient, I believe, would be a somewhat dynamic layering system. It's not, it wouldn't just be fixed and static. It would be fluctuating up and down day to day, hour to hour, depending on how much is being produced and how much is being consumed. So your gradient is actually your pressure relief area. Does that make sense?
I understood every part of that.
I understand it.
Yeah, I thought that was good, Effie. That was good.
Yeah, that was pretty good.
The daily heat cycle with the sun could affect it as well.
Yep.
All right, now,
Yeah, all
now
of
may-
those things.
Thanks,
yeah,
Effie.
now
That was
may I
great.
say something? Because I'm going to add
PSI. There is
some
no
clarity to this.
fucking pressure. No human could live
Right.
in 14 psi. It's ludicrous.
Right.
Go ahead,
First of all, earlier you were talking about gauge pressure and absolute pressure, Brian. So that's why that makes sense when you said.
Shite. I don't want
Right. Regardless.
Just let him get it. Let him get it out so we can shoot it down.
No, he talks fucking rubbish.
I know.
Yeah,
just let him talk his rubbish, and then we'll shoot it down.
And you know, Brendan, gauge pressure. What he said about the menstrual cycle and the tears. Gauge pressure refers to referencing the atmospheric pressure and then adding to it. So when they say it's 1 psi of tears or whatever, they're adding to the atmospheric pressure. So I'm not talking shit. I actually know what I'm talking about, and I'm trying to correct you. But regardless.
It's 14 psi out here. That means it's got to be over 14 psi in the body. You fucking.
That's
idiot.
right. That's exactly right, and that's what it is.
No.
That's what I was just referring to.
No vein would take that sort of pressure, you twat.
Yeah, that's why it's called gauge pressure.
You're a fucking idiot.
I mean, look it up. I mean, you can just Google the word
Shut
gauge
up.
pressure and see what it says. But regardless,
you doing way too much. Calm down. We just having a conversation. You screaming, yelling, calling people twats and all that. Why we can't just have a conversation without all the disrespect?
regardless of the disrespect, it's fine. I can.
Just like months away.
to reprogram.
It's a conversation.
I got it,
bro.
Brian.
Why are you
I
screaming
got
and
it,
yelling
Brian,
for
but-
and disrespecting
It's
people?
not a conversation. He's trying to reprogram you. That's what his job is.
He can't reprogram us though, Brian. He can't do it, man.
Yeah, we're all safe here, Brian.
Why
It's
the
just a
fuck
conversation.
He will not listen to us.
I
So why
like
the
how this
fuck
guy
should we
came in.
listen to it?
Bro, maybe
Yes, I
this
just
is a
posted
bit too much for
conversations in
you if
chat,
you
I mean.
can't.
Fuck off, you
I mean, if you can't control yourself, maybe this conversation is a bit too much for you.
No.
I mean, the rest of us are just having a conversation, and you screaming and yelling and getting all out of hand. Maybe this is too much for you, brother. Maybe you
Brian,
need to
you
just
calm down.
leave.
Not too much for me. You will understand if you are genuine, which I don't think you are. I think you're part of it anyway. You will understand that Kosho and his crew are here to reprogram us. Nothing else. They do not listen to.
All right, guys. I think we're gonna call it a night on the Discord. It is 8:30. To be honest with you, I'm tired. I'm out of gas. Be back on Monday. I'm gonna put out a couple of after shows this weekend if you guys are into that sort of thing. One is an absolute train wreck that I don't suggest anybody listens to, but you'd be surprised there are people out there who like to listen to absolute disasters. You will know it when you see it if you are looking for it. But there's a couple other good ones, so check those out. They'll be on my channel, Brandon Toy, and you can watch those for what they're worth. Actually, there is a good one. It was like 4 hours. It was one day after Bev was here, and I think there was a couple other people that joined afterwards. Very good stuff. Some really good conversations in that one. That one will be the one without the dumpsters on fire. So look for that. My channel, Brandon Toy. I really appreciate it. Shout out to Good Servants, 99-cent sticker. Appreciate that, man. And you guys have a good weekend. We'll be back on Monday. I got some stuff lined up for next week. Got a couple people will be coming into the show. A couple outside people. Got a couple other things in the work. Should be interesting stuff. Jim Panda might come over and, as Brian would say, try to reprogram us. We can see if we can have a good conversation with Jim. He's a pretty interesting guy, but there might be a lot of yelling during that one. We'll see how that one goes. But thanks, guys. Have a good night. Have a good weekend. I lost my music for my outro.